The time frame of these two techniques is different. The time frame for the co-citation analysis is the past, while for bibliographic coupling, the present and the future. Of course, both of these methods have their own set of advantages and limitations. The co-citation analysis, on the one hand, enables a historic overview of the research field under study, and it enables us to identify the most important publications. However, the limitation is that because citations are need time to accumulate, newer publications can get neglected. On the other hand, bibliographic coupling detects the current state of research and enables the identification of future trends. However, the limitation is that it is harder to identify whether the mapped publications are important for the studied field. So to basically form and visualize the bibliometric networks, we used the software package WasViewer, which we also complemented with the software package SITNET Explorer, and we can find a detailed explanation of these two software packages in Vanek and Waldman 2010 and 2014. So let us now move on to the results. Based on our obtained data set on research on circular economy in the fields of business and economics, we found out that the research field is still relatively young, although it has clear antecedents already in the 1960s. However, regarding circular economy in economics and business, the two oldest articles stem from 2007, and over the years, the research field has gotten a lot more globalized. Here you can see a map of countries publishing research on circular economy in the fields of business and economics. You can see that research is appearing all around the world. However, Europe remains the leader in this type of research. The most published articles can be found in the United Kingdom, followed by Italy, Spain, as well as China. Also interesting is that although we were looking at the fields of business and economics, research is interdisciplinary, multidisciplinary, and also most of research can be found in the Journal of Cleaner Production, followed by sustainability, as well as resources, conservation, and recycling. So let us now move on to this picture of the most important keywords. Basically, the map of keywords in this research field shows the following. We can see that we have 4 clusters of different keywords. A qualitative analysis revealed that the red cluster of keywords is more technology-oriented, while the green cluster is more business model-oriented. The third biggest cluster, the blue cluster, mostly concerns articles dealing with China as well as industrial symbiosis, while the yellow cluster can be seen as a bridge between the green and the red cluster, because you can find basically both. You can find articles, keywords on business models as well as technology-related issues. In the next picture, there is a citation network of articles on circular economy in the fields of business and economics, which is based on bibliographic coupling. And based on this basically picture, we see that there are 3 key directions in which research is currently heading. First one, let us look at the blue cluster of articles. A qualitative review revealed that this cluster mostly concerns research on the macro level. It concerns industrial symbiosis, institutional change, as well as different trans-interdisciplinary explorations. On the other hand, both the green as well as the red cluster mostly concern research on the meso as well as micro level. The green cluster mostly concerns circular economy business model development, while the red cluster basically also concerns circular economy business model. However, those models are heavily linked to digitalization, big data, as well as Industry 4.0. Among all three clusters, there is a certain degree of overlap, uh, especially regarding supply chain management. So the last thing we wanted to find out is basically to see where research is still needed to actually to get companies to embrace the circular economy. So we also conducted an analysis of articles in our data set who have the highest usage count. The problem with citation is that they need time to accumulate. Therefore, we wanted to know which are the articles that are currently most interested in by the academia. So the usage count tells us which articles were the most downloaded in the last half of years. And we see the following. We found out that there are three main directions of articles that have the highest usage count. One direction is peculiarities of sustainable supply chains. The second direction is waste management, a step back to assessing the end of life values. And the third one is circular business model innovation, testing and improving existing models. And now our conclusion basically is that our findings suggest that while the theoretical progress is remarkable, as well as the analytical approaches are very, very sophisticated, companies primarily need a proof of concept, which remains somewhat limited. Therefore, we believe that scholars need to refocus on action-oriented research to ensure that the circular economy is impactful as presented in the literature. The truth is that companies will not proactively change their steady state unless something has been proven to work. And we, as circular economy scholars, we have to accept our role of active agents that help companies redesign their operation. This is basically it. These are some of our references which you saw. And I would thank you very much for having me and for the time you gave me to present our poster. Thank you very much.
Thank you very much, Dr. Miha Domingo, for your nice presentation. Hello. Okay, so I would like to go for the questions. So do you have any questions for Dr. Miha Domingo? You're most welcome to come up with any of the queries, or you can post your queries in the open chat box available at the bottom. Okay, it seems there are no questions. So I would like to tell the participants that we will having a refreshment break for 10 to 15 minutes. So hope you can have some good refreshments, and we will be back within 10 to 15 minutes. Thank you. Thank you, Renewable, for your patience. I hope you have very good refreshments. And we will start the presentations now. So we just got a update from Dr. Sanjay Kumar. So he's not available with us. So I would like to move on for the next presentation presenter, Dr. Ramesh V. Kundamchiri. Dr. Ramesh, are you ready to present now?
Yes, I am ready.
Yeah, thank you so much. So let me introduce about you, brief. Dr. Ramesh V. Kundamchiri is a chartered engineer and fellow of Institute of Engineers from India. He's an MTech graduate in quality management from Pila Institute of Technology and Sciences, Pilani, and he's a research scholar at University of Petroleum and Energy Studies at Tehran, India. He has published several papers in solar thermal EOR field and is a senior professional working in the energy industry. His area of expertise is project and contract management. He is a certified project management professional and certified project risk management professional by the Project Manage Institute, United States. And I would like to call upon now Dr. Ramesh Viki to present the topic on the application of renewable energy in heavy oil industry, which is a history of solar thermal EOR and demonstration of energy and energy performance of an existing solar steam generator. Dr. Ramesh, you're most welcome to begin your presentation now. Thank you.
Yeah, is it visible now?
Yes, we can see your screen very perfect. Yeah.
Yeah. Okay. Good morning, all of you, and thank you very much for the nice introduction. Basically, I'm a person working in the oil and gas industry, and take out some time to do certain research in the area where I work. So my topic for today is application of renewable energy in heavy oil industry. In that application, I'll be briefly touching upon history of solar thermal enhanced oil recovery, and in small portion, I will demonstrate the energy and exergy performance of an existing solar steam generator. So before I go into the topic, let me say a cautionary word that I'm facing a very low bandwidth today. So if I face any issues in between, I will have to switch the connection. So please bear with me. So this is the contents or presentation outline. In the first section, I will be discussing about solar thermal EOR. What is it? And it's basically the concepts associated with it. And then I will go through the history of solar thermal EOR, when it was started and how it progressed and what is the current level of technology available in the industry. Then we will go to a relatively new concept, which is glass housed enclosed parabolic trough collector type steam generator. And then we will go to the energy performance analysis of a GPTC system, which is actually installed in the Middle East. And for the same system, we will look at the exergy performance analysis also. And then we go to conclusions. Yeah, let's see why we need this sort of setup in the industry. So we have in oil industry, there are conventional developments and unconventional developments. So in unconventional oil developments, we have a couple of classifications, but major one is the heavy oil, heavy and viscous oil recovery. So in enhanced oil recovery, what we do is we just try to increase the recovery factor of the reservoir, which means we apply some technology so that we can take out maximum oil available in the reservoir to the surface. So it's basically the petroleum engineers language is they will try to increase the sweep efficiency and displacement efficiency, or both, of the oil, so that it can be easily pumped out from the reservoir. So that is called enhanced oil recovery. I have a slide coming up. Yeah, so we have different oil recovery mechanisms available now. So it's basically primary oil recovery, secondary oil recovery, and tertiary oil recovery. In the primary oil recovery, it is natural flow and artificial lift. You just drill a well and put a pump and pump out. And in the secondary oil recovery, we have a couple of mechanisms like water injection and gas injection. At one side of the reservoir, you inject the water or a gas, and then from the other side, you lift the oil and take it out. And in the tertiary oil recovery, we have several mechanisms, out of which the predominant one is thermal enhanced oil recovery, which means we just heat up the reservoir or the oil surrounding area, so that the viscosity of the oil will come down, and which will eventually enhance the mobility of the oil, and it will become easy to pump it out. So in thermal enhanced oil recovery itself, we have different mechanisms like combustions, steam assisted drive, steam sock, steam drive, hot water. So if you look at the thermal oil recovery, steam is an important parameter. So basically, to heat up the reservoir, we inject the high pressure, high temperature steam to the reservoir. So in conventional thermal EOR, what happens is that steam is being produced by burning fossil fuel. Earlier it was conventional fluid fuels, but now we are using the natural gas to natural gas fuel to convert water to high pressure steam in steam generators. This is the conventional method. But in solar thermal method, what happens is that steam is produced by harnessing solar energy. Further, there are different technologies used for steam generation, even if we apply solar energy. So I'm going to take one particular technology, and we are going to see the analysis. So let's see the history of solar thermal EOR. Solar thermal EOR, the concept was introduced in the year 1982. The research or the papers available in the research world shows that in 1982, there was a paper published, the anticipated effect of diurnal injection on steam drive efficiency. So basically, since the solar energy is diurnal, but the reservoir wherein we wanted to produce the oil, they need a continuous supply of steam. So what is the effect of this diurnal injection of solar steam? So this was analyzed in 1982. That was the history available, start of the concept available in history. So if you look at the practical applications, in 1983, there was a company called Arco Solar. They put up a 1 megawatt capacity plant in California, and this technology was power tower, which you can see in the second picture over here at the bottom. So wherein the flat solar mirrors will be kept at one side, and it will be focused onto a tower wherein the water will be pumped continuously. From there, the water will get converted into steam. So this is the power tower or solar tower technology. So that project was introduced in 1983, and then there was a big gap, almost 3 decades, we should say. Nothing has happened on the technology. The reason being, earlier stages, the solar project was very costly, and we had EC oil readily available. Enhanced oil recovery was not required. We were in a position to drill a well in oil bearing reservoir and produce it by
So I would like to apologize all the participants that Dr. Ramesh has facing a technical issue.
Sorry, I'm back. I didn't know when I lost, so I was continuously
Yeah,
showing.
it's okay. You can continue from now.
Yeah, okay. Let me. Could you please let me know where you lost me? Here.
Yes.
So this slide was complete, I suppose.
It was history of solar.
Yeah, okay. Then I'll go to the next one. Yeah. Okay, I'll start afresh on this slide. Basically, the first point when we started the solar thermal EOR, it was in 1982. The concept was introduced. The diurnal effects of solar steam on the oil production was analyzed in a paper in 1982, as early as 1982. And in 1983, this was put out to what you call action, and then a pilot plant was completed by a company called Arco Solar in California. So it was a power tower concept wherein you have flat mirrors on one side, which will eventually focus full sunlight to a tower wherein water will be pumped, and at the focused focal point, the water will get converted into high pressure steam. So this was in 1983. So after that, there was a big gap, almost 3 decades. Nothing has happened. The reason being, the solar project at that point of time was very costly and it was a sort of luxurious thing. And we had EC oil available in the market, which means that without applying any complex technologies, we were in a position to produce oil in cheap. And then in 2011, there came up a new technology called enclosed parabolic trough, which is the first picture in the slide. So it shows all the parabolic collectors are put inside a glass house. There is a reason why it is kept like that. I will come to it later. That was done by a company called Glass Point Solar, and it was again in California. It was a 250 kilowatt power plant. And then in 2011 again, there was a much bigger project came up by Bright Source company. It was 29 megawatt capacity, and it was again in California. Going to the solar thermal projects in the Middle East, in 2 years later, in 2013, a project came up in Middle East in Sultanate of Oman. The company which invested is Petroleum Development Oman. I was a staff of Petroleum Development Oman, and that is why I got a chance to work with this project and then could do certain research on this. So it was a 7 megawatt plant, and it was commissioned in May 2013. It was again a pilot plant based on enclosed glasshouse enclosed parabolic trough collectors. And once the pilot was completed in 2013, the company was much satisfied about its performance because it was producing high quality steam, and steam was very much required in the oil field to do the thermal enhanced oil recovery. So in 2015, another project of 1 gigawatt capacity conceptualized, and the project went ahead, and the first phase was completed in commissioned in 2017. I heard that they have plans of completing it at a later date, but after 2 stages, now it is they are waiting for the performance performance analysis and all. So it's pretty well working. The plant is currently working. The plant is called MIDA. it's available in the internet or anywhere, because this was one of the major projects in the Middle East to capitalize the or harness the solar energy for heavy oil fields. Now let's see how the it's again conceptual details of how the solar thermal EOR by glasshouse enclosed parabolic trough collector works. In glasshouse enclosed parabolic trough system, which we are going to analyze here, is a direct steam generation. Means at one side of the receiver tube, water is pumped, and on the other side, you are getting the steam out. So the first figure on the top, it is the schematic. Water is supplied from one side to the solar field, and it's in an enclosed trough parabolic collector, and on the other side you get steam. Parallelly, there is a connection for which feed water to once through steam generator. It's a natural gas fired steam generator, and both combine the steam, and then it goes to the injector wells to inject into the reservoir. So this OTSG is required in case of an inclement weather wherein we cannot produce steam with solar. Then we have to have the backup, and also during night, if steam consumption is required, we have to have the OTSG. So this setup is employed. So now coming to the second picture, we have the parameters, how the analysis is done. We have the glasshouse enclosures, the green one, and the receiver tube running at one side, water in the green side, and on the other side we have the steam coming out. So the the letter Q denotes the energy input. QS is coming from sun, and there are some losses here, and then it goes to the QPTC. Whatever is received at PTC over here is getting concentrated onto the receiver tube QRT, and then with that the steam is produced. So here on the right side of this picture, we have the cross-sectional details of the parabolic trough. It's a standard one. Yeah, this is an actual picture to visualize what I'm talking about. So the first picture is an external picture from outside of the plant, wherein we can see the parabolic trough inside, and the glowing line sort of thing. This is the receiver tubes, and it is already on action, which means the sunlight is being concentrated onto the receiver tubes, and water is getting pumped. So if you look at the second picture, it's a picture from inside. The parabolic troughs are on park mode. It is not getting concentrated onto the receiver tube, and people can go in. Probably it is in the early morning hours, so person is walking inside. Glasshouse is marked. Now let's see why we need a glasshouse for a heavy oil field. So in Middle East, particularly where I have the experience, in Middle East we have the heavy oil fields almost in the desert area, and the first picture shows everything. It's quite common that heavy sandstorms do occur. If you look at the first picture, you can see the flare running here. So this is a heavy sandstorm. So if we don't have a glasshouse enclosures, the situation will be very bad. There will be a lot of sand deposit on the curved area of the parabolic trough, and it will be very difficult to clean. And water is a scarce commodity in these sort of areas. So it was not recommended. So if the advantage of having the glasshouse enclosure is shown in the other two pictures. In the left side picture, it's a top view wherein you can see this guy. This is a robot, and it is an automatic working on automatic sequence, and it is cleaning the glasshouse, and it's with a very less water requirement, which itself can be reused. And this is a side view. So basically the glasshouse is required to protect the parabolic trough, and it gives a lot of advantage for cleaning and all the activities. Now coming to the energy assessment for glasshouse enclosed parabolic trough collectors. So this picture we have already seen, and the table on the right corner, it's the design parameters of the parabolic trough. It's a big topic by itself, so we are not going too much into the detail, but the basic details are in the energy assessment. What we do is that we apply the first law of thermodynamics, wherein we say we can find that the net energy falling on the any object is being utilized to increase or change the internal energy plus doing some work done. So this fundamental principle is applied here, and we calculate the first law of energy. If we apply the first law of thermodynamics to each component of the installation, like glass house, PTC, receiver tube, and then we can have the first law efficiency as eta first law is output energy by input energy. So this is being done. Now, this is the result of that study. What we did was we took different readings for 12 days, and it is based on the previous analysis, it is mapped, and we found out what is the overall efficiency and what is the efficiency of the PTC, parabolic trough collector, and receiver system efficiency. So it is found that PTC receiver system efficiency and overall efficiency are very close, and they follow the same pattern. And the efficiency is the overall efficiency is coming around 50-55 maximum, and it hovers between 45 and 55 depending upon the climate, the radiation level, and all those things. Now we have losses. So this is a slide which shows what are the losses involved and what relatively how much it is. If the total loss is 100%, if you look at the maximum loss is happening on the middle portion, which is the energy loss and radiation concentration. This means from after falling onto the PTC, it gets concentrated onto the receiver tube. So that process has loss of maximum losses. This is important to note it here because we have some conclusion about it at a later time. And then comes the thermal losses within the receiver tubes, and we have certain unaccounted losses. Unaccounted losses are the losses which we cannot model in with the equations, because there are certain amount of what you call it's not redundancy errors. If you allow me, just a second. I'm sorry. Yeah, the thermal losses are the losses which happens in the receiver tube in converting the water to steam, and we do have modeling for frictional losses. Okay, now then comes to the exergy performance assessment. Exergy is a different term. Actually, energy analysis says the law of conservation of energy, but according to the second law of thermodynamics, the exergy come into picture, which link the energy with the entropy. Entropy is the disorderness of the system. So it says something about the quality of the energy also. It says the maximum work potential. Exergy is the maximum work potential, or it's a sort of reversible, how much reversible work how much useful work can be extracted from the system. That is the concept of exergy. So in exergy also, similar to energy analysis, what we did was the applying the second law, and then we have the equations derived for calculating what is the second law efficiency or exergetic efficiency. It is the desired output divided by the maximum possible output. So we can't have in what you call full energy in the analysis. We can't convert full energy into useful energy. There will be always some losses which is irreversible in nature. So that is exergy. So that principle is applied for exergy assessment. So similar to energy analysis, for the same reading, we have drawn the exergetic efficiencies or second law efficiencies. It shows the exergy efficiency, overall exergy efficiency is maximum is around 40%, and PTC receiver system follows the same trend, and it is very close to each other. Losses also follows the same trend, but it is more exergetic destruction. It's not losses, it's exergy destructions. And yeah, now coming to the comparative assessment of first law and second law efficiencies. As always, the first law is based on energy conservation. Basically, the assumption is that energy is always conserved. We can there is no losses. There is no irreversible losses. But in exergy efficiency is always less than the energy efficiency. And here is the comparison. It's almost 15%. 15% is the difference. Yeah, this is the slide showing the cumulative exergy destruction assessment for the assembly, which says the exergy destruction for the radiation concentration is comparatively lesser, and exergy destruction at receiver tube is the maximum. So there is an inference which we will be coming out in the conclusion section about it. Yeah, the highest loss of energy was taking place in the PTC during radiation concentration process, and second highest loss element was the losses in the receiver tube. But the highest exergy destruction was taking place in the receiver tube, and second highest exergy destruction was occurring in the PTC during radiation concentration process. So it's the reverse in exergy calculations and energy calculations. It's the reverse. So there are some designers who follows only the energy analysis for designing the plant. So here comes the importance of the exergy analysis. Exergy is the useful work what we get. So we have to conduct the analysis always based on the exergy, because if you do only based on energy analysis, we may get misplaced or misguided in the process. So had the design followed based only on heat loss and thermal efficiency aspects, this point would have been missed out. Yeah, that's it from my side.
Thank you very much, Dr. Ramesh Vike, for your nice presentation.
Any questions?
Yes, so I would like to go for the audience now. So do you have any queries for Dr. Ramesh? You're most welcome to ask him so that he can able to answer your query. If you'd like to interact with him directly, you can ask him, or if you want to type your queries in the chat box, you're most welcome so that I can address your queries to him.
Okay.
Yeah, okay. Thank you so much, Dr. Ramesh, for your time today.
Thank you.
Yeah, thank you so much for your presentation as well. And now I would like to go for the next presenter, Shiriyang Zhang, from the Beijing University of Chemical Technology, China. Shiliang Zhang is a graduate student at Beijing University of Chemical Technology. He conducts research on dangerous gas diffusion and pollution source traceability in lab of fluid flow and heat transfer and IGCIT. His research and fields include safety engineering, algorithm, and fluid mechanics. Shriyank Zhang, you're most welcome to share your presentation on the back calculation of source intensity position based on a combined genetic on intermediate simplex algorithm.
Hello, everyone. Welcome to my speech about back calculation of source intensity and position based on a combined genetic neodymium simplex algorithm. Due to the leakage of pollutants and dangerous chemicals, accidents emerging one after another, and it also causes serious and far-reaching damage to the environment. We can see from these two pictures, when the leak occurs, people near the source of the leak are the first to get hurt, and then harmful substances will be carried into the environment by the atmosphere. There are two accidents caused by leakage of the dangerous chemical. The first accident resulted in the death of 4 people and the injury of another. Residents 60 kilometers away could also smell the pungent smell of meth cell, but fortunately, it did not direct damage. During the second accident, because of the unaware of the situation at the site of the leak, the inspectors did not wear any protective equipment, which directly led to the poisoning of 3 people. In the end, the accident resulted in the death of 2 people and the serious injury of another. From these 2 accidents, we can find out that in the process of dealing with these problems caused by leakage, the most difficult work is often how to quickly and accurately find the source of leakage to protect the site personnel and also prevent the further spread of pollution. From the source term information to the consequence of the leak, in recent decades, emergency workers often based on the mathematical model and the computer simulation of the atmospheric dispersion process of the gas leakage describes the dispersion process of release of substances in the environment and transportation, obtaining leak material concentration of time and space distribution for related departments to do personnel emergency evacuation to deal with the toxic substances to provide a theoretical foundation and basis. There are 2 main models. The first model is computational fluid dynamics models. It is called by CFD models. CFD models are the most accurate model for situations in complex scenarios such as transonic or turbulent flows. However, the computational fluid dynamics model needs a lot of computation time and is not suitable for emergency treatment of accidents. The next one is Gaussian dispersion model. Gaussian dispersion model assumes that the released pollutants have a density equal to the air density and are released horizontally into the atmosphere at a speed equal to the wind. To achieve this condition, the compound should have been sufficiently diluted by the atmosphere that the released compounds are sufficiently distant from the point source. Therefore, Gaussian dispersion model is only applicable to the prediction of the ranging far from the point source. Gaussian dispersion model is through several transitic simplifications, such as the point source or the perceived dispersion from the early stage of release. It is allowed for obtaining a system of equations analytically solvable. So Gaussian dispersion model is suitable for emergency treatment of accidents. From the consequence of the leak to the source term information, the proper emergency action depends mainly on knowing the source locations, the source emission rate, and the likely future dispersion routes of the release. The methods for estimating source term parameters usually are divided into two categories: probability or statistics methods and optimization methods. Probability or statistic methods. But source term to estimate pollution results can be same as a forward modeling method. Assuming the strength and the location of the leakage source within a certain range and substituting the forward model, the concentration of each point in the field under the assumed conditions was calculated and compared with the observed results of the detection node. The above process is repeated until the calculated values at each node are consistent with the observed values, at which point the estimate source term is consistent with the actual value. It requires a lot of observation data for statistics and is not suitable for fast source term estimation. Optimization methods. This method establishes the inverse problem according to the forward model, deduces the information of the source term from the observed value of the detection node, and searches for the optimal solution of the inverse problem. In this process, the inverse problem can also be formulated as a linear optimization problem, which cost function is given by the least square difference between the measured and simulated concentrations by the mathematical model. CFD models. About optimization models, CFD models, logarithm models, and Euler models are not suitable for fast source term estimation because they would consume a lot more time than the Gauss models to finish a forward simulation process. So we can say the Gauss models are more suitable for fast source term estimation. We always divide optimization methods into three main kinds. The first one is indirect optimization, such as the Newton method and the gradient type search. The second kind is direct optimization, such as the near-mid simplex method. The last kind is intelligent optimization, such as genetic algorithms, practical swarm optimization, and simulated annealing. However, we can say each single method has their weakness. So what is our goal? We are chasing for the speed and accuracy when face an emergency leakage. To achieve this goal, we have to overcome the inevitable defects of the single algorithm. Our team try to mix near-mid simplex method and genetic algorithms. Step 1, problem formulation. We will establish point source dispersion models. From this picture, it's assumed that the leakage source is located at the coordinate. The wind direction is only along the x-axis, and the wind speed is consistent. We established two models which are all based on the Pascal G-fold dispersion model. The first model is a Gaussian-Plume model, which describes the steady state concentration of a substance released by a continuous source. The second model is the Gaussian path model, which describes the internal concentration of a single substance after the release of a given amount. Now we should formulate a reverse problem. It assumed that n sensors are set in the downwind direction of the leakage source to measure the concentration value of the leakage material. Assume that the calculated concentration value of the ice position obtained from the dispersion model is measures the concentration value for the sensor at the corresponding point. Then the objective function is f is set as the sum of the squares of arrows between the measured concentration value and the calculated concentration value, such as this. Now the location and the strength determination of the leakage source are transformed into the solution of the optimization problem, and the hybrid genetic nailed meat simplex algorithm is used to gradually optimize and adjust the Q0, X0, Y0, and Z0 that minimize the objective function as optimal values and of the required solutions. Step 2, solution of the model. We use the hybrid genetic nailed meat simplex algorithm to solve the model, and the solution process was divided into 2 stages. The first stage is the global search stage. Firstly, the genetic algorithm is used to conduct a wide range of search in the solution space of the optimized objective function, and the initial point near the global optimal solution is found for the nailed meat simplex algorithm. This is a flow chart of the global search. In the global search stage, using genetic algorithm to find the approximate global optimal solution in the search space is an intelligent search method. Compared with the other analytical expression search methods, genetic algorithm can automatically updating the optimal search space and adjust the search direction adaptively in the global search stage. Genetic algorithm is used to first find the approximate global optimal solution. N+1 set of the values in the search space. The following steps are mainly achieved in the global search stage by using genetic algorithm. The second stage is the intensive search stage. Nailed meat simplex algorithm is used for further optimization to speed up the search speed and finally find the optimal solution. This is a flow chart of the intensive search. And now we need to verify that the algorithm works as expected. We start the verification from instantaneous release. By comparing the reverse calculation results of the variables and of the instantaneous source and with the source strength of the actual leakage source, it can be found that the error has been very small. These 4 pictures are inverse parameter optimization processes of Q0, X0, Y0, Z0 in instantaneous release. So we can see when the cycle reaches 35 times, the inverse result of each parameter is good, and the time taken is 8.9 seconds. And then this is a verification of continuous release. By comparing the reverse calculation results of the variables of continuous source with the source strength of the actual leakage source, it can be found that the error has been very small. And these four pictures are inverse parameter optimization process of Q0, X0, Y0, Z0 in continuous release. So we can see when the cycle reaches 30 times, the inverse result of each parameter is good, and the time taken is 6.5 seconds. Conclusions: by comparing the change value of each inverse calculation parameter with the expected value in the two examples, it can be seen that even if the initial value selected is far from the optimum value, and the final result with a small error from the expected value can be found. Two examples are given to illustrate the feasibility of applying the hybrid genetic nailed simplex algorithm to the inverse calculation of source strength and location. It can quickly and accurately inverse calculate the source strength and location variables of the leakage source, and is suitable for the emergency management of hazardous chemical gas leakage pollution accidents. We collected all the modules from the model to the algorithm and programmed them into independent software using Java language, making the transability process no longer dependent on simulation software such as MATLAB. This is the input interface of the software. You can change various parameters in this interface, such as crossover rate, mutation rate. This is output intervals of the software. You can also change the model as you want, because we all know the basic model are not very accurate. About future work prospect, the basic gauss dispersion model is not suitable for the traceability of leakage source under complex environment and Terry conditions. The model also fails to deal with small diffusions in the near field. Nowadays, we are trying to improve the model to make it suitable for the traceability of leakage source in the near field. In the natural environment, the wind direction and the speed are constantly changing. And one of the requests for using this program to calculate is that the wind direction is consistent with the direction of the axis, which requires the program to adjust the coordinate system according to the wind direction signal abated by the sensor. This makes traceability with fixed location sensors possible. In response to this problem, our team are improving the software. Thanks to Beijing University of Chemical Technology and my professor, Dr. Jianwen Zhang, and our partner company, Shanghai HGIoT Technology Company Limited. Thank you.
Thank you very much, Dr. Zhang, for your presentation on the back calculation of source intensity using an algorithm. So, do you have any questions to Shiliang Zhang? So, if you have any questions to ask Shiliang Zhang, you're most welcome so that he can answer your query. Okay. Thank you very much, Zhang, once again for your nice presentation. Yeah, and we will move for the next presenter, Miguel Centariate.
Good afternoon.
Uh, Hello, Miguel Centariate. It seems there is a lot of disturbance. Yes, it is okay now. Miguel Centariate is a PhD student in environmental engineering in British Magnus University Agriculture Academy. Her field of study relates to the biodiesel to diesel fuel mixtures production by using in situ transerification process and biocatalysis, lipases. Also, the evaluation of physical and environmental properties of products obtained. Now, I would like to call upon Miguel Centariate to share her presentation now. Thank you.
Good afternoon, everyone. First of all, I would like to say thank you for giving opportunity to participate at this conference and present my research work. I am Niglia Shantaraite, last year PhD.
Miguel Centariate, hello.
Hello.
I'm sorry to interrupt you in the middle, but we can hear a lot of disturbance from your end. Can you please check your surroundings because we can hear a lot of sound from your surroundings. So just check your microphones. There is a lot of disturbance from your end.
Is it good now?
Not it. Still, we can hear disturbance.
And now? Maybe better because I don't know what to do.
Okay. You can decrease your volume and you can continue, as I think that is only option.
Okay. Maybe better now?
Okay, can you decrease your volume or lower your volume to some extent?
Yes, I did, but still.
Yeah. So I would like to suggest you one thing. Can you log out and log in again so that it may
Yes.
work out okay?
Yes.
Okay. Yes, please. You can log out and you can log in again.
Hello.
Oh, yes. Hello.
Is it better now?
Yeah, it seems better now. Yeah, thank you.
Can I start?
Yes, yes, you're most welcome. You can start now.
Can you see my presentation?
Yes, we can see very perfect. Please go ahead.
Okay. So good afternoon again, everyone. First of all, I would like to say thank you for giving opportunity to participate at this conference and present my research work. I am Emilia Shantaraite, last year doctoral student. My scientific advisor is Professor Eglė Senčikėnė. We are from Republic of Lithuania. It's a country in the Baltic region of Europe with a population of 2.7 million. Its capital and largest city is Vilnius. Other major cities are Kaunas and Klaipėda. Here you can see our Vytautas Magnus University's Agriculture Academy campus. The subject of my presentation today is biodegradability and life cycle analysis of biodiesel to diesel fuel mixtures B10. This presentation will last for about 20 minutes. So if you have any questions, I will be pleased to answer them at the end of my presentation. This presentation will be in three main parts. Firstly, I will introduce my research scientific relevance, aim, and objectives. Secondly, I will focus on the research conditions and methodology. And in the end, I will present results which we received. So let's start with scientific relevance. This research is relevant because by using mineral diesel as an oil extraction solvent, it's possible to refuse one stage of a process, pressing or extraction of oil from seeds. This would prevent additional energy and material costs. This biodiesel production method allows producing immediately mineral diesel and biodiesel blends B10. As a result, it's no longer necessary to mix the produced biodiesel with diesel, which reduce energy costs. Another advantage of research is that high acidity oily seeds used for the production of biodiesel. Due to poor transporting or storage conditions, about 10% of total harvest of rapeseed lose its quality. The acidity of the oil often exceeds norms suitable for human or animal consumption, so there are no competition with the food industry. Consequently, these seeds become biological waste, and the right way to reuse them must be found from energy and environmental point of view. In this slide, you can see comparison between two basic biodiesel production processes, conventional and in situ, which is direct oil extraction from seeds and its transesterification to biodiesel process. So the main differences between these methods is that in situ process is reduced one stage of biodiesel production, no longer necessary to obtain oil from the seeds before its transesterification. The aim of research is to investigate optimal conditions of enzymatic in situ transesterification process by using mineral diesel and alcohols, methanol, ethanol, or butanol mixtures in order to produce legal mineral diesel, biodiesel fuel blends B10. The objectives to reach this aim are as follows: to choose optimal biocatalyst suitable for in situ transesterification process, to explore possibilities of producing mineral diesel biodiesel fuel blends by using low quality rapeseeds in diesel fuel media and by using different alcohols, to optimize optimal conditions of process, and to extract maximum amount of rapeseed oil as well as fully convert rapeseed oil to fatty acid methyl, ethyl, or butyl esters. Now I would like to move to part 2. In particular, The aim was to determine which lipase is most suitable for in situ process by using high acidity oil from rapeseed. 11 different lipases were analyzed according to the following primary conditions. So mineral diesel and rapeseed oil ratio was 9:1. Alcohol, methanol, ethanol, or butanol and rapeseed oil quantity was 5:1. Amount of lipase 7%. Temperature of reaction 40 degrees and time for reaction 5 hours. The optimal lipase suitable for in situ transesterification process by using different alcohols was screened by thin layer chromatography. Yields of rapeseed oil and rapeseed methyl, ethyl, or butyl esters from reaction products was analyzed by Fourier transform infrared spectroscopy. The degree of transesterification and the quantities of glycerides, mono, D, triglycerides was evaluated by gas chromatography. Gas chromatography is the most important method at our research. The samples produced must meet requirements of biodiesel standard. Some of these indicators are glyceride levels and degree of transesterification. These parameters are determined with a gas chromatograph. Now let's move on part 2. Here I will acquaint you with the results being obtained. So to optimize conditions was choose mineral diesel rapeseed oil ratio 9:1, alcohol and oil quantity 5:1, temperatures of reaction 25, 30 or 40 degrees, durations of reaction 1, 3, 5, 7, 9 hours, amount of lipase, lipozyme TLEM was choose for 3, 4, 5 or 7%. It was found that optimal conditions for in situ transesterification using alcohol, methanol, ethanol, or butanol and lipase lipozyme TLEM was as following. Molar ratio of alcohol 5:1, amount of lipase preparation 5% with methanol and ethanol, 6% with butanol. Duration of reaction was 5 hours with methanol, 7 hours with ethanol and butanol. Temperature of reaction 25 degrees with methanol, 30 degrees with ethanol and 40 degrees with butanol. All these optimal conditions, yields of rapeseed oil and rapeseed methyl ethyl butyl esters in reaction products were more than 99.8%. All degrees of transesterifications were about 99%. Glyceride contents in the products comply with the requirements for biodiesel fuel. After finding the optimal conditions to produce fuel mixtures, the purpose of a study was to determine how the biodegradability of fuel mixtures are improved compared to the degree of biodegradation of mineral diesel. Biodegradation was assessed according to manometric respirometry method, its assessment of oxygen consumption. Device used for measuring biochemical oxygen demand was BOT system AL 606. After 28 days, pure mineral diesel biodegrades to 20.64%. Pure rapeseed methyl esters after 28 days biodegrades to 96.40%. The results show that almost 2 times faster biodegradable diesel biodiesel fuel mixtures containing rapeseed oil methyl esters. It is 37.27%. Fuel mixtures containing of 10% of rapeseed oil ethyl esters and rapeseed oil butyl esters improved biodegradation by 2.94% and 2.27% more than mineral diesel, respectively. This is likely due to shorter methanol radical chain compared to ethanol and butanol esters. All produced fuel mixtures were evaluated according to life cycle assessment by using CIMA Pro software with choosing CMLEA baseline method. 10 environmental impact categories have been assessed, such as global warming, eutrophication, acidification, ozone layer depletion, and so on. The environmental impact was compared to that of pure diesel impacts. Fuel mixtures containing of 10% of biodiesel have positive effect and significantly reduce all these negative environmental impacts. So thank you for listening to me. I will be pleased to answer any of your questions.
Thank you, Miguel Santeri, for your nice presentation. Thank you very much.
Hello, good afternoon.
Hello.
Hello, good afternoon.
Good afternoon.
Yes, please. This is Dr. Ibrahim calling from Air Force Institute of Technology, Kaduna, Nigeria.
Yes, hello.
Yes, please. Thank you very much for the nice presentation.
You're welcome.
Yes. I don't know, have you considered stability before subjecting the mixture of the fuel to biodegradability analysis?
Mm-hmm. Excuse me.
Yes, I'm talking about stability. Have you considered stability?
Yes.
Because I know the mixture of biodiesel from any feedstock mixing with the conventional diesel, there is a problem of stability.
Yes, I'm sorry, but I don't hear you very well.
Yes, hello? I don't know whether you reported the degree of the stability of your fuel before subjecting it to the biodegradability analysis. That is my concern.
Oh, yes. Yes, we report it in our manuscript. But today I show only the basic results of biodegradation.
Yes, I understand. I said before subjecting the fuel, any mixture of biodiesel and diesel to biodegradability analysis, there is need to, do the stability test, stability analysis to know that your fuel is homogeneous in mixture, which reported in the literature is about 0.01% of the stability before doing the gradability analysis. The question I ask is that have you subjected your fuel, your mixture, to that stability analysis before biodegradability?
Oh, yes, now I understand. No, we didn't.
Okay. So maybe you can consider that one in the future work.
Yes, thank you for this consideration, really. It's a good advice.
It's okay. Thank you.
So still any more queries for Miguel Santariat? You're most welcome to ask her so that she'll be able to answer your queries. So you'll be having 2 to 3 minutes of time. So if you have any further queries, you can ask Miguel Santariat. Okay, it seems there are no questions. I would like to thank again Magil Santarate for her nice presentation. And I would like to go for the next presenter. Iwe Guide. Iwe Guide is a PhD student in environmental engineering in Vitatis Magnus University Agriculture Academy. Her field of study is related to the heterogeneous synthesis of biodiesel using natural rocks as heterogeneous catalysis. So, Dr. Gay, you're most welcome to share your topic about dolomite as heterogeneous catalysis in biodiesel synthesis. Thank you so much.
Hello, thank you for the introduction. Can you see my presentation?
Yes, we can see your presentation and we can hear you perfect. Thank you.
Okay, thank you. So, hello one more time. I'm Yava Gaida. I'm a PhD student in Vytautas Magnus University Agriculture Academy. My scientific advisor is Professor Violeta Makarevičienė, and today's my presentation topic is dolomite as heterogeneous catalyst in biodiesel synthesis. I'm from Lithuania, from Kaunas. Lithuania is a small country on the eastern shore of Baltic Sea with population of 2.8 million. Lithuania has 4 neighbors, and it is Latvia, Belarus, Poland, and Russia, Kaliningrad. So, what about the relevance of the research? First of all, as I would like to say that as environmental pollution increases due to greenhouse gas emissions, the use of fuels obtained from renewable energy sources gain more and more interest. The majority of studies globally are related to the improvement of conventional biofuel production by applying transesterification process. Production of biodiesel based on heterogeneous catalysis has the main advantage because of the easy separation of the catalyst from the final product. And in this research, we use the heterogeneous catalysis, and as heterogeneous catalyst, we use dolomite. Dolomite is a natural mineral rich in calcium compounds. These calcium compounds can be converted into calcium oxide, and it is known that the calcium oxide is good catalyst, which can be used in biodiesel synthesis. The purpose of the research was to investigate optimum conditions for biodiesel synthesis from rapeseed oil and butanol using dolomite as a heterogeneous catalyst. The scientific objective of the research was to investigate optimum conditions for dolomite preparation before transesterification reactions. We investigated 2 conditions, the dolomite fraction size and the temperature of the calcination. And then we optimized the conditions for transesterification reaction. 4 conditions were investigated: the alcohol to oil molar ratio, the catalyst amount, the reaction of the reaction duration, and the temperature of the reaction. What about the methods that we used? So first of all, we determined calcium oxide and magnesium oxide, which is also known as good catalyst for biodiesel synthesis. So we determined the amount of these oxides in the dolomite that we used. It was done by a complexometric titration method. All the transesterification reactions were conducted in the conical flasks, which were connected to condensers, thermometers, and mixers were used. Optimum conditions for catalyst preparation were analyzed by thin layer chromatography. Ester yield was evaluated by gas chromatography. The experiments were planned and results were analyzed using response surface methodology. For this, design expert version was used. And as I mentioned earlier, 4 independent variables were used for the planning the experiments. First of all, butanol to oil molar ratio was analyzed, and it was selected from 5 to 15 moles. Second, the temperature of the reaction from 60 to 110 Celsius degrees. Then the catalyst, in this case dolomite, amount from 3 to 9%. And the last one was the duration of the reaction, and it was selected from 2 to 8 hours. There were total 30 experimental trials. Now I would like to talk about the results that we got during the research. First of all, we found that the dolomite which we used contains more than 29% of calcium oxide and more than 19% of magnesium oxide. When we selected the optimum conditions for dolomite preparation, first of all, dolomite fraction size was optimized. And here we can see that the optimum fraction size was from 0.315 to 0.1 millimeters. The second parameter was temperature of the calcination, and the optimum calcination temperature was obtained at 850 Celsius degrees. And under these conditions, dolomite was prepared before the transesterification reactions. Then, as I mentioned, 30 experimental trials were modeled by response surface analysis. The highest predicted ester yield was 94.78% when the butanol to oil molar ratio is 15, temperature of the reaction 110 Celsius degrees, dolomite content 9%, and the reaction has to take 8 hours. After the experimental part, we found that under these conditions, ester yield is 94.55%. Here in figure 3, we can see the interaction between catalyst amount and butanol to oil molar ratio when the process temperature is 110 Celsius degrees and reaction takes 8 hours. As we can see, ester yield increases, increasing alcohol to oil molar ratio. However, from some point, it starts decreasing when increasing the butanol to oil molar ratio. And the highest ester yield obtained when butanol to oil molar ratio is 12.5 moles. In figure 4, we can see the interaction between catalyst amount and the temperature of the reaction. When the butanol to oil molar ratio is 15 and process takes 8 hours. We can see that the reaction temperature has a great influence to ester yield. However, the catalyst amount is not so important factor, because as we can see from when the catalyst amount is from 3 to 9% and the reaction temperature is 110 Celsius degrees, the ester yield is obtained more than 95%. And in the figure 5, we can see the interaction between process duration and the temperature of the process when the catalyst amount is 9% and butanol to oil ratio is 15 moles. Here we can see that the reaction duration has also the great impact for ester yield, and the longer duration, the higher ester yield is obtained. The final part of our research was the optimization of rapeseed oil transesterification process. It was done by response surface analysis. The response surface analysis gave us two options to get the 94.55% of ester yield. In first option, the butanol to oil molar ratio has to be 13.72 moles, a reaction temperature 110 Celsius degrees, concentration of dolomite 5.24%, and reaction duration 8 hours. After the experimental part, the ester yield was obtained under these conditions. Ester yield was obtained 94.89%. And the second option was the butanol to oil molar ratio 10.02 moles, the same reaction temperature 110 Celsius degrees. The concentration of catalyst 6.59% and the same duration 8 hours. And under this condition, the experimental ester yield was 94.65. So as we can see, the predicted ester yield was the same in both options. However, the reaction temperature and the duration of the reaction is the same. However, in the first option, butanol to oil molar ratio is higher, and the concentration of catalyst is lower. When if we, in the second option, if butanol to oil molar ratio is lower, the dolomite amount has to be higher. And to conclude the research, dolomite that we used as heterogeneous catalyst contains more than 29% of calcium oxide and more than 19% of magnesium oxide. The optimum conditions for dolomite preparation, including milling and sieving to 0.315 to 0.1 millimeter fraction, and the optimum temperature of the calcination is 850 Celsius degrees. It was found that the biggest influence for transesterification process has the reaction temperature and the duration of the reaction. And after the optimization of heterogeneous rapeseed oil transesterification with butanol and methanol process, the following optimal conditions were obtained. As I mentioned, the two options were obtained. In both, the reaction temperature has to be 110 Celsius degrees and reaction time 8 hours. In first option, butanol to oil molar ratio 13.72 and dolomite amount 5.24%. In the second option, the butanol to oil molar ratio 10.02 and the dolomite content 6.59%. And under these conditions, the yield of rapeseed oil butyl esters were 94.89 and 94.65%. So thank you for your attention, and if you have some questions, I would be pleased to answer it.
Thank you very much, Dr. Ivagate, for your excellent presentation. So any queries to Dr. Ivagate? You're most welcome. So later on, if you have any queries, you can contact John Wesley, or you can contact her via email. That is displayed on the screen. Yeah, okay. Thank you so much, Kriva Guide, for your nice presentation once again.
Yeah, thank you.
Yeah, you're welcome. And now I would like to call upon Sanjeev Kumar um, to share his presentation on use of flumentous fungi for bioharvesting and pre-treatment algal biomass for biogas production. Uh, Dr. Sanju is a biochemical engineer by background and researcher by profession. He obtained his Bachelor of Engineering in Biochemical, Kumaon Engineering College, Uttarakhand, Master of Technology in Biotechnology at Anna University, Chennai, and PhD in Environmental Bioprocess and Bioenergy at Indian Institute of Technology, Delhi. Dr. Sanju is currently working as assistant professor at IIT Roorkee and heading the Environment and Biofuel Research Group at the department. His major research focus is on environment, bioprocess, climate change, bioenergy, rural development, water and waste, water treatment, algal biofuel, phycromation, waste valorization, GHG emissions, and water bodies management. Dr. Sanjesh Kumar, you're most welcome to start your presentation now. Thank you.
Thank you very much for nice intro. Let me share my presentation first. Yeah, I hope these slides are visible to everyone.
Yes, we can see your slides.
Yeah, thank you. So, so I will be talking briefly about a short part of my research, which is focused on the use of fungi, particularly just to improve the production of biofuel from algal biomass. And my major focus has been towards the biogas production. So I have given my email address here. If you have any query, which may not discuss here, you can directly write to me. Okay. So, so this picture shows a general diagram for the process of algae to biogas production. So which we have projected in a review which was published in 2014. So this process says that the algal cell wall will be degraded with the help of some exoenzyme, which will be produced by the hydrolytic bacteria. Then this will lead to release of some of the molecules which are already available in the algal cell inside the cell. So then these hydrolytic bacteria will act on the macromolecule to convert these into the monomers, mainly sugar and amino acids. And the second stage will be the acidogenic, which is very common in the anaerobic digestion process, during which the bacteria which are involved in this stage will take up these monomers and then will convert into small volatile fatty acids along with some amount of alcohol and aldehydes, etc. And then before the final stage will reach, the acidogenic bacteria will act on these substrates which has been formed so far to convert them into acetate and CO2 and hydrogen. And finally, methanogenic bacteria and the anaerobic microorganism in the system will take up these acetates, etc., to convert into biogas, which is a mixture of methane, CO2, and hydrogen. So this is an overview of the process which actually occur inside the reactor when we are interested to produce the biogas from the algal biomass. So the problem with the algal biomass which we have noticed so far during last 10 years of research. So you can see the picture which are showing the algal cell. So these are the samples of the picture of the samples taken from the anaerobic digester that was operated for 45 days. And you can clearly see the algal cells, which are in fact present even after 45 days of anaerobic digestion. So this shows that the digestion of the algae under anaerobic conditions is not proper. So there are few possibilities. We have highlighted two. One, like the cell wall resistant to the anaerobic digestion process, the one major limitation. Secondly, when we analyze the C-wine ratio of the algae, which was less than 9, and it is well reported for the anaerobic digestion to occur at a fluid scale, the C-wine ratio should be in the range of 15 to 25. So this was low. So these are two reasons for the poor digestibility of algae in the anaerobic digester. So based on these two limitations, there may be some possibilities like algal biomass treatment may be opted to improve the digestibility. And secondly, we should focus on the waste which can be co-digested with the algal biomass just to improve the C-wine ratio. So we have worked on these two aspects. So firstly, I'll discuss about the pre-treatment aspect. Then there is one result which I'll show related to the co-digestion. So what actually happened actually when we come to the algal cell wall? So it is well known that the algal cell wall is composed of so many polymeric substances, mainly complex polymers, including the cellulose and hemicellulose, which is obviously very difficult to be degraded under an anaerobic digestion process. So and mostly the cell wall is up to 75%, 70% of the cell wall is composed of cellulose. And in some cases, the researchers has reported that the cellulose of the algal cell wall may contain some other molecules like xylose rather than the glucose also. So for this, there are several methods like physical pretreatment, mechanical methods also, but we opted for the biological method that too based on the enzymes. And when we come to the enzymes, there are few studies which shows that using the commercial grade enzyme, we can improve the biogas production from the algal biomass. But as we can see that the cell wall is composed of different kind of molecules. So rather than using a pure enzyme, we should use a cocktail. And for that, the crude enzyme produced from the fungi can be used for the pretreatment of algal biomass. And for this, we use two strains, Aspergillus lentulus and the Rhizopus oryzae, which were available in the lab and have been reported to produce a good amount of the enzymes, including cellulose and xylanase. And we use two substrate like sugarcane bagasse, agro residue, and corn cob, another agro residue, to be used as a substrate for enzyme production. So after producing the enzyme, we analyze the activity of the crude enzyme in terms of cellulase activity as well as xylanase activity. So as you can notice that the cellulase activity was highest in case of the A. lentulus enzyme produced on the sugarcane bagasse, and the xylanase activity was again highest with the sugarcane bagasse, but that for the Rhizopus oryzae. So based on the finding, what we did, we initially developed a method which is known as dual fluorescent assay and has been published in algal research for the very first time by our group. So what we did, we analyzed the pretreatment effect of the crude enzyme on the algae with the help of cytoxanthrin. The beauty of cytoxanthrin is that it cannot penetrate the algal cell wall if it is not damaged. And if it is damaged, it will penetrate to the algal cell wall and it will bind to the DNA and will give green color under fluorescence. So you can see in this picture, the green cluster shows the presence of the damaged cell wall algae. Those are showing the green color, and the red color dots are the intact cells. So the red color is due to the autofluorescence of chlorophyll. So this confirms that the enzymes are acting on the algal cell wall. And we have seen that because of the action of the enzymes, the cell wall is being degraded and the cytoxanthrin is able to bind to the DNA of the algae. Later on, we carried out a brief or very preliminary work just to confirm the pretreatment quality of the algal cell with the help of the enzyme. And for that, we use the two enzymes at different doses, 10% volume by volume and 20% volume by volume. So it was clearly observed in case of AL at 20%, the Aspergillus lentulus enzyme at 20% shows the maximum pretreatment, which was confirmed visually. And when we did some microscopic analysis, we found that the pretreatment is quite good in case of the AL at 20%. So that was confirmed with the scanning electron microscope as well as DIC micrographs. Then for quantification, we analyze the cell death just to represent that how the enzyme is acting on the live cells and how the cells are decreasing. So again, in line with the previous observation, the AL at 20% shows the maximum death rate, and almost 100% cell death was achieved within 48 hours of the incubation with the crude enzyme. That again were confirmed with the help of the fluorescent microscope, again the cell cytometry, in which we analyze the sample at the AL at 20% and RO at 20%. The RO is the Rhizopus oryzae crude enzyme. So you can clearly see the difference. Here, after 48 hours, the dots are very less, which shows that only few cells are left. But in case of the RO, the dots are relatively higher. So which shows that the AL crude enzyme is more far better than the RO crude enzyme. So later on, we work towards the quantification of the data in terms of the biomass solubilization, which was reported in terms of the soluble COD release as well as sugar release. So it was observed that within 48 hours, again the AL 20% shows the highest biomass solubilization, that was around 30% on dry weight basis. So that was recorded under the incubation of the algal biomass with the AL crude enzyme at 20%. And the respective sugar release was up to 55 mg per liter from the same sample. So we did the visual observation, we did the microscopy, and finally we confirmed the result with the quantitative data. And those were in agreement with each other that the AL crude enzymes are having the better efficacy towards the algal biomass pretreatment. And the effective crude enzyme concentration, which was estimated for 20% volume and volume, was around 9.39 FPU per gram of dry algal biomass. Yeah, so one limitation is that in this process, we have to incubate sample up to 48 hours. And the major reason was that we randomly selected some parameter, like we mixed the algae with the crude enzyme, and we did not optimize the temperature and the pH. And the temperature for the pretreatment studies was around 30 degrees centigrade. But through the literature, we found that the optimal condition for the AL crude enzyme are different. So we opted the optimal conditions, which are like pH of 5 and the temperature of 60 degree. And we observed that with these optimal conditions, the sugar release reached up to 60 mg per liter within 2.5 hours. So rather than going for 48 hours, we just received a good result or at par with the previous value within 2.5 hours. And same happened with the CO2 solubilization from the biomass that increased up to 50% within 2.5 hours, again at optimal conditions. Okay, so non-optimal conditions shows up to 33.9 in 48 hours. And whereas the optimal condition shows up to 51% CO2 solubilization, that too in 2.5 hours. So with the optimal conditions, we reduced the incubation time to 2.5 hours. And that too resulted in high release of algal substances, which were already packed in the algal cell wall. Then finally, what we did, we took the pretreated algal biomass and we analyzed the sample regularly with the microscope just to ensure that the algal biomass has been pretreated with the crude enzyme. And we performed the anaerobic digestion studies to monitor the effect of the enzymatic pretreatment on biogas production. So we noticed that the methane potential, the production was improved to 324 ml per gram of volatile solid from the initial value of 255. That was for the untreated biomass. And in another word, we can say that the digestion time can be reduced with the by the 15 days, because when we compare the data, like pretreated algae showed at par value of the methane yield, which was reported in 30 days. And for the pretreated, it was observed in 15 days only. Along with the digestibility was also improved to 49% from the previous value of 35%. And the volatile solid reduction rate was improved to 66%. And the hydrolysis constant that was obtained from the Gompertz equation modeling was also improved from previous value of 0.03 to 0.08 per day. And then finally, what we did, we combined the pretreatment with the co-digestion, and we selected two substrates. One is the sugarcane bagasse that was obtained after the enzyme production, and the cattle dung. And we found that it's a better suited with the cattle dung, and the highest methane production of more than 13 ml of methane production per gram of volatile solids was observed in case of the pretreated algae when digested with the cattle dung. And there are few advantages of the cattle dung, that it improves the C/N ratio, and in addition, the cattle dung also serve as extra microflora to speed up the process. So that's why the highest methane yield was observed when we combined the pretreatment of algal biomass with the cattle dung. And the second problem which I'll talk today about is the harvesting. So everyone knows when we cultivate the algae under the photobioreactor or in the raceway, the nature of the cultivated broth is very diluted. And sometimes we have to separate the algal biomass, and there are several physicochemical methods which are very energy intensive. So we should avoid those methods. And after, like, if we start like here, algae has to be cultivated, then we have to separate the algae with the several methods. Then algal biomass has to be pretreated. Again, we have several physicochemical methods, but energy and cost are involved. So if we use the fungi, we can replace these two crucial steps in a single go. So that was the objective of this work. If we have seen that the fungal crude enzymes are very good in terms of the algal biomass solubilization. And if these fungi can also be used for harvesting of algal biomass, that will add the value to the work. So that in that way we started, and we started with the hypothesis with that, like the fungi is having the positive charge on the its surface, and the algae is having the negative charge. So there were possibility that these two may combine through the electrostatic forces, and there may be some hydrophobic sites which may improve the algal harvesting with the algal biomass. Or it was also hypothesized that the algae can bound to the fungal hyphae with the help of some metabolites which are being secreted by the fungi itself. In any case, the algae will be bound to the the fungal pellets, which are very easy to be settled down at the bottom. That's why we can easily harvest the biomass. And with the start of this work, we initially worked with the pre-grown algae, and we inoculated all the algal flasks with the spores of the fungi. And if we are starting with the spores, we need to supply the carbon source, so that we, in that case, we use the glucose at different concentration to support the growth of the fungi. So in that case, the light was there, the algae was growing, and the fungi was also growing because it started from the spores. And we observed that after some time, the spores are forming into the pellets. So overall, when we see this work and we find that the glucose concentration of 5 gram per liter is required to have up to 100% harvesting of the algal biomass within 24 hours. So there were two limitations. One thing is that high cost glucose is required. Secondly, the time was of 24 hours. So we worked again to reduce the time requirement and to avoid the glucose input. So what we did then, so this is just for your information. If you want to know more about this work, it has been published in the bioenergy resource. So instead of using the fungal spores, what we did, we used the pre-grown fungi. Okay, and that too we cultivated using a waste carbon source. Like fungi were grown in a growth media, supplemented with the waste carbon source, which I'm not interested to disclose here because of some IPR issues. So that pre-grown fungi were taken, and again we tested two sets. One set, the dark line are having the without glucose supplementation, whereas the dotted line are with the glucose without the glucose supplementation. And we observed that the fungi to algae ratio of 1:3 resulted, without the glucose supplementation, resulted up to 100% harvesting of algal biomass within 6 hours of incubation. So rather than going for 24 hours, we reduced the process time to the 6 hours only. Then we validated the process at reactor scale, and we found that the results are comparable with the flask scale studies, and almost all the biomass was harvested within 6 hours of incubation, like 6 hours of cultivation of the algae with the fungi. So that fungi which has been pre-grown, and we harvested the pellet and we added those pellet to the reactor. Then the next task started for the pre-treatment. So we stopped this reactor, we harvested the biomass, and we stored that biomass under controlled conditions, provided there was no light for the algal growth, but conditions were like that it should support the growth of the fungi. And because the algae have lots of fixed carbon in their cells, it was assumed that the fungi will try to grow on the algae, try to extract the carbon from the algae, and in that way the fungi can result in pretreatment of algal biomass. That again happened actually. So what happened, we regularly monitored the sugar concentration from these samples and the enzyme activity. You can see here AF is the algal fungal pellets sugar release, algae means A is the algae alone sugar release, and this EA is for the enzymatic activity. So for the enzyme activity, we measured the cellulase activity only. So we noticed that around at 3 days, there was maximum release of the enzyme activity in the stored sample, and the sugar release was highest at 4 days. Okay. So with that, we confirm that if we can harvest the algal biomass using the fungi and we incubate the algal fungal pellets under controlled conditions, it will result in the treatment of algal biomass. That's why we are replacing both the steps that require the separation of algae initially, and then separately we have to pre-treat the algal biomass. So we are combining these two in a single go. Okay. Then what we did, we performed some BMP analysis like biochemical methane potential assessment. So for that, we analyzed the different algal cells. You can see A is for algae alone, and AF is the algal fungal pellets that has been incubated for 0 day, 1 day, and so on up to 5 days. So you can see that highest biogas production was observed when we choose the sample which was incubated for 3 days. So algal fungal pellets incubated for 3 days shows the highest methane production from the sample. So that confirms that if we are harvesting the algal biomass with the fungal pellets and we are incubating under controlled conditions, obviously the methane production from the algal biomass harvested in such a way will improve significantly, which you can see here. At the same time, you can see that A3 here, algae alone without the fungi, and AF is the algal and fungal pellets. So you can see clearly you can see the difference here. Okay. And this work has been published in Green Chemistry. You can follow the article if you like it. And overall, the process is like that. The innovation in the algal harvesting was that we are using the pre-grown fungi to harvest the algae. We validated the result at reactor scale. And finally, we confirm that the pre-treatment is occurring when we are incubating the algal fungal pellets under control condition. And we notice that there is a improvement in the biogas production when we incubate these samples under control condition. So this is the way we analyze. Initially, we started with the fungal crude enzyme. Then we turn towards the harvesting of algal biomass using fungal pellets. And then finally, we combine the process in which in a single step or in a single process, you can harvest the biomass and you can improve the digestibility. And for this interesting work, we have recently granted with an Indian patent. And based on the so far discussed data, the lab observation, we also work to recycle the digested from the liquid of the anaerobic digestion of the algal biomass to be used as an algal cultivation growth media. And those experiments were very much successful. And we found that the liquid digested, if it is being recycled from the anaerobic digestion unit, it supports very good growth of the algae. And based on that, we proposed calculation for 1 meter cube biogas production plant per day. So that plant will require the biomass, which will in turn treat the wastewater, including the wastewater as well as the liquid digested at a rate of 2600 liter per day. So in turn, we'll get the biomass, which will produce the biomethane up to 1 meter cube of per day. So this is the proposed diagram. So we have gone beyond this. We have done some experimental work, which I'm not going to discuss here. So we have done some pilot scale studies with the algal biomass and pretreatment of the algae, and then performing the pilot scale biogas production under environmental conditions. So that's all about the process which I was interested to discuss in the today's conference. So this is my team. I have given some link for my lab page and the profile. If you're interested, you can go through. And this is my team. Those are working with me. Like Mohit is working on the algal and nanoparticle to improve the biofuel production. Mamta is working on the wastewater treatment along with the algal-based metabolite production. Akansha is working in an innovative way to link the constructed wetlet with the algal biomass just to improve the wastewater treatment and bioenergy recovery. Again, Ankita is working on the pathogen removal from the wastewater treatment, like sewage treatment plant. We have focused on, and we are working on the algae-based treatment, and we are also looking to recover the energy from the wastewater treatment. And Pooja, who has recently joined, is working on the wastewater treatment as well as GSG emission from the water bodies. Thank you all for your attention. If you have your queries, you can ask.
Dr. Sanjeev Kumar, I would like to thank you very much for your excellent presentation.
Thank you very much.
Yeah, so I would like to go for the participants. So if you have any queries, you can ask Dr. Sanjay Kumar. Or his email is displayed on the screen at the first. So if you have any queries to be emailed, so you can contact him via email as well.
So my email address is here. Participant can note it down. And if you have any query, you can directly contact me. So I will be happy to address your queries.
You can have Dr. Sanjay Kumar email at sanju at hre.iit.ac.in or sanjukec at gmail.com. Yes, I would like to thank you once again, Dr. Sanjay Kumar, and I wish you and your group a very success in this project as well. Thank you so much.
Thank you very much.
And I would like to go for the next presenter, and I would like to call upon Dr. Abdul Rahman Yankudi from King Saudi Arabia University, King Saudi University. Dr. Yankudi obtained his BSc degree in chemistry from Taiwan University in 2015. Immediately, he worked for Chemical Club at his university, expanded his experience by working in the water analysis laboratory of Saudi Bin Group for 3 months. He joined Bournemouth University for English classes for a year. Afterwards, he joined the Renewable Energy Master Program at King Saudi University, where he's doing his research in dry reforming of methane as a tool for hydrogen production. Dr. Abdul Rahman, you're most welcome to start your presentation now. Thank you so much.
Thank you very much for this introduction.
You can see your screen?
Yes, good. Good afternoon for you, and thank you for your effort in this conference. On behalf of my lab mates and my professor, I'm going to present this work, which is the optimizing of jet humidifier for hydrogen production over zirconia-supported nickel catalyst via dry reforming of methane. The outline of this presentation is the background. I'm going to speak about the methane reforming and the greenhouse gases and the advantage and disadvantage of the greenhouse gases, the objective of this work and methodology, which is contained the experiment setup and the catalyst preparation, the result and discussion and conclusion. Sadly, the greenhouse gases has been increasing in our atmosphere, which is majorly CO2 and methane. These greenhouse gases lead to a serious problem, which is climate change and ozone hole. The major source of the greenhouse gases are human factor, which can be controlled. The source of the greenhouse gases, which is the 3/4 of the greenhouse gases, are come from the transportation, electricity generation, and industrial application. For the solution for this problem is using renewable and sustainable energy for transportation, such as hydrogen cars and electric cars, using renewable sources for electricity generation, such as solar energy, wind energy, and hydropower. Methane reforming methods. Steam reforming is the traditional method for producing gas, which is a mixture of carbon monoxide and hydrogen. These methods are widely used in industrial level, which is a combined which is from methane and steam at very high temperature. Partial oxidation of methane, which is instead using steam, using oxygen to produce ethane gas. And our work is the dry reforming of methane, which is gain great interest through utilizing the greenhouse gases, such as methane and carbon dioxide, to produce an equal molar ratio of carbon monoxide and hydrogen. Certainly, many studies are being carried out to develop this method to be industrial level to produce hydrogen from greenhouse gases using nickel instead noble metal such as platinum to its availability and cheap price. The researcher has made a huge effort to advance these catalysts to industrial level, and the good catalysts have good properties such as the interaction between the active metal and the support, the dispersion of the active metal such as nickel on the surface of the catalyst, basicity. This is one of the most important factors to you in your catalyst to be highly activated. Hydrogen storage capacity, reducibility, pore size, and surface area. As any technology has its benefit and drawbacks, the big advantage is for dry reforming is possibility of using greenhouse gases and low process temperature, promising and attractive methods. Hydrogen is not required for the start of this reaction. And disadvantage and throwback is the low percent of molar ratio between the hydrogen and carbon monoxide. The carbon deposition, which is one of the most important factors to deactivate your catalyst. The objective of this work is study the role of support zirconium oxide and zirconium oxide modifier with different loading of yttra on the performance of nickel catalyst in dry reforming. Catalyst preparation. We use impregnation methods to produce the catalyst. The first step is the calculation for the catalyst based on the weight percent of the catalyst. The next step is we need hot plate, crucible, and magnetic bar to prepare our catalyst. When the nickel, which is the active metal in our catalyst, completely dissolve in water, we add the support and we heat at 85 degrees Celsius for 3 hours. When all the water evaporate and the mixture becomes slurry, we move to drying, which is the next step, which is took a longest time to prepare this catalyst, which is took 18 hours to produce the catalyst and heating for 120 degrees Celsius. And the last step is the calcination. We calcinate the catalyst for 700 degrees Celsius for 3 hours. The experiment setup. The experiment setup is composed of 3 factors, which is the feed section, which is the contain the gases we need for our reaction. All these gases are equipped with high purity gases, which is nitrogen, carbon dioxide, methane, and hydrogen. All these gases are filtered and delivered with mass flow control. When all these gases are mixed together, they go to the next section, which is the reaction section. All the reaction section happen in this section. Okay. We have a stainless steel microtubule. Overall length is 30 centimeter, and inside diameter is 1 centimeter. And we have here the catalyst bed equipped with a thermocouple to measure the temperature inside the reactor. To activate our catalyst, we need to produce hydrogen in 20 ml per minute for 1 hour. And then the feed come, which is the methane and carbon dioxide, carry out with the nitrogen to heat our system. When the reaction is done, we go to the analysis section, which is contain a gas chromatography GC equipped with the TCD detector and 2 column position in parallel. All the gases are analyzed by this machine. For a TBR is showing us the interaction between the active metal and the support. We have here in the red line, in the red peak, is our base catalyst without any modifier. And in the blue peak, the addition of 5 yttra. In the green, the addition of 10 yatra. In the red and the orange, 15 and 20. We can see from this picture the black peak, which is our base catalyst, have the highest hydrogen consumption. When the addition of yatra with low weight percent increase the interaction, which is made all the catalysts shift to the higher temperature. When addition of yatra with higher percent loading, such as 15 and 20, then the interaction becomes suitable and become to a lower temperature, which is from 500 to 300 degrees Celsius. The hydrogen consumption of our base catalyst is the highest, then the 20 yatra. As the interaction increase, we need more power to break this bond between the nickel and the support. So the activation must be done at higher than 650 for this reaction. Carbon dioxide, TBD, is one of the most important techniques used for determine our basicity. Because the acidic behavior of carbon dioxide and methane, we need a base surface to make the reaction done on it. So using zirconium oxide and yatra have this feature. We can see here the 15 yatra have the highest basicity based on this figure and have carbon desorption at very strong range, which is at 700 degrees Celsius. From the area under the peak, we can find out the quantity of carbon dioxide absorbed. In order, 15 yatra have the highest basicity, and then 10 yatra, and then 5, and the base catalyst, and then 20. We can find out there is a huge drop in basicity in 20 yatra, which is shown in the orange. XRD analysis. The XRD analysis are showing all the catalysts have the same pattern from our support without any active metal, but we can see clearly all the intensity are decreased. We can see here the intensity of nano-zirconium oxide without any active metal is higher than our base catalyst, and etc. As addition of yatra, the intensity of our catalyst is decreased due to dispersion of the active metal. And this XRD analysis shows all the zirconia have one phase, which is monoclinic zirconium oxide, which shows in this peak at 15 and 20, etc. All these peaks have monoclinic zirconium oxide. And we have only one phase of cubic nickel oxide, which is shown in these peaks, which is at 32 and 35 and 45. Unfortunately, the yatra doesn't appear until we increase the loading. It shows this peak showing the yatra at 15 and 20. Here is the yatra is clearly shows. From XRD, we can reach to the nickel oxide. As we increase the yatra, the dispersion of the nickel oxide which is increased, which is in our plus. The conversion of methane. The methane is the source of our hydrogen, which is the core of our thesis. As the conversion of methane increased, the hydrogen production has increased as well. This our base catalyst, shown in the black line, showing very poor activity. The addition of yatra enhance the catalytic performance from 5, which is in the blue line, which is start at higher point, which is 63, and decrease, which is not in our catalyst. We want very stable catalysis, which is appear at 15 yatra, which shows a very high conversion if you compare it to our base catalyst. There is like the improvement of more than 35% from average 40 to 65 in methane conversion. 10 yatra showing promise to continue the loading until we get our optimum loading, which is 15 yatra. We can see here in the orange line, the addition, this catalyst is 5 nickel, 28% of yatra show drop in our activity, which is due to 2 reasons. Because, as we said before, the interaction between the nickel and the zirconium oxide and basicity. Carbon dioxide conversion. The carbon dioxide conversion is higher than methane due to reverse water gas shift reaction. Here the conversion is, in average, is about 72%. If we look at our base catalyst, the conversion is very, very poor. It is nearly 40%. So this huge enhancement in the catalyst due to the addition of yatra. And all the catalysts have the same trend, which is 15 yatra is the best catalyst and the optimum loading, and then 10%, and then 5% and 20 yatra. The hydrogen production, which is our core for this thesis. We need a very high hydrogen conversion and hydrogen yield. As the reactant conversion, we get a higher production of hydrogen. And this reaction is done for 7 hours. Based on this 7 hours on a stream of carbon dioxide and methane. They are both deposition and produce hydrogen. The hydrogen has followed the same trend as before, which is a 15 yatra showing the high percent yield, and then 10%, and then 5, and then 20. We can see here is the stability in hydrogen production for all the catalysts is not promising, to be honest. We show that the deactivation factor is decreasing. It's not like the carbon dioxide conversion, showing very steady conversion. A TGA is about the study the carbon coke formation on the surface of the catalyst. Here, as the weight percent loss is compared to carbon formation. So, carbon formation is equal to weight percent loss. As the loss increasing, the carbon formation is increased, which is not in our side. We need a catalyst with low carbon formation. The addition of yatra, it doesn't improve this. So we can see here our baseline in the red catalyst is showing here. All the catalyst doesn't show improvement in carbon formation, except if yatra with 2%, which is not considered very high. Conclusion: the addition of yatra to the catalyst improve the catalytic performance and stability, and the conversion rate of methane and carbon dioxide. A 15 weight percent yatra was the optimum loading found. The conversion rate of the carbon dioxide increased from 64% to 71.8%. The methane conversion rate has increased from 35% to 65%. And the hydrogen is increased from 33 to 61, which is a very huge number. The most effective aspect in our work, which is increase the basicity of our catalysts, which have the more role to improve the catalytic performance. as we increase the basicity, the conversion, and the rate as increasing. Thank you for your precious time, and any question, I'm really happy to answer it.
Thank you very much, Dr. Abdul Rahman, for your nice presentation on enhancing oil production.
Thank you very much.
Yeah, thank you so much. So, any questions to Dr. Abdul Rahman? You're most welcome to ask him so that he can be able to answer your queries.
Yeah, thank you so much for the nice presentation, Mr. Abdurrahman. We really appreciate your effort, what you have put together. I just want to ask a question. From your presentation, you concluded that the addition of Yatra did not really improve the catalyst in terms of reducing the carbon deposit.
Yes,
so
true.
What is your recommendation? What can you recommend? What can you recommend in order to reduce the carbon deposit? Like we all know in catalysis, carbon deposition is a big problem.
Yes, it's true. What you're saying is true. To improve the catalytic performance and the carbon decomposition is the addition of magnesium. But the problem is, if you addition of the magnesium, maybe the yield is going to be decreased. So this is our solution, to try to addition a little percent of magnesium or alpha alumina to our catalyst.
Thank you.
Thank you very much.
Thank you very much, Dr. Rahman, for your response and clarifying the questions. Still, any more questions to Dr. Rahman?
Thank you very much.
Yeah. Thank you very much, Dr. Abdul Rahman, for your presentation once again. Thank you. Okay, and here we go for there are almost 4 presenters from now. So from the countries United Kingdom, France, Iran, and Brazil. So the presenters will be late, joining late with us. So in the meanwhile, we will be having a break for 30 minutes. So you can have your refreshments, can have your tea or coffee or lunch. So then we will be back within 30 minutes. And keep stay tuned.
Claro, ya va. ¿Ah? Ah.
Yes, hello everyone. Hope you had a very good lunch breaks, and thank you for your kind attention and patience as well. So now we'll go ahead with the next presenters. Dr. Somaya Sabri. She was born and bred in Iran. She studied physics, astronomy, and graduated her PhD course 2 years ago. She has been working as a postdoctoral researcher at the University of Tabriz. During her PhD, she had an opportunity to be in Belgium with Professor Dr. Stefan Poit's team for 6 months. Dr. Sabri, you're most welcome to begin your presentation now. Hello. Oh, hello, Dr. Somaya Sapi. Can you hear me? Dr. Somaya Sapri, you are online, maybe due to technologies, you can hear me or not, I don't know, perfect. Uh, so I would like, yes, hello.
Hello. Hi,
Yes,
everyone.
yeah, hi. Hi, Dr. Sabri. You can start your presentation now.
Thank you.
Dr. Somaya Sabri, is there any technical issue regarding sharing your screen? Oh, we can hear some interference as well as some echoes, but we cannot hear well and we cannot see your presentation as well.
Do you share my screen or?
Yes, you can share your screen.
Because I send it. Okay.
Okay, do you want to share your PPT? Do you want me? Do you want
Yes,
to?
yes, I try.
Okay.
Yeah, I try to share my PPT, but can you share it because I send it by email?
Okay.
Can you share it for me? My
Yeah.
PPT file?
Okay, just allow
Because I
me.
think that it's it needs more time for me to share it. Yeah.
Yeah, okay, just allow me a moment. I'm going
Thank
to
you.
read.
Thank
Yeah.
you. Thank you.
Okay, I was requesting my colleague to send your PPT. Okay, just allow me 2 minutes of time.
Okay, thank you.
Okay, okay. Dr. Soumya, meanwhile, can you share your screen because there was error while my colleague is sending your PPT. So in the meanwhile, can you share your screens? I will catch up with your presentation.
Said, do you share my PPT or I should do it?
Time being, I would like to request you to please share because my colleague was sending your PPT, but it was not reached yet for me. So I would like to request you to share your PPT. So is that okay for you? Or else,
I try to wait.
okay, or else, can I go with the next presenter, Dr. Farida Amrauchi? Dr. Farida, are you ready to present now? Oh,
Okay, hello. Yeah, I'm ready. Just I don't know if I'm going to share the screen or you have already my presentation with you.
yeah, okay. Dr. Somi, I will share your presentation after Dr. Farida finishes her presentation. Is that okay for you?
For me, whatever you decide
Okay.
on.
Yeah. Okay.
Yeah, sure.
Yeah.
Thank you. Yeah, okay. I'm
Yeah.
here.
Okay. Meanwhile, I will
Okay.
find your PPT and I will catch up with your PPT. Okay. So I would like to request now Dr. Farida to share her presentation and begin her presentation now.
I'm going first. Just please give me a couple of minutes to download it from my email.
Yeah, it's okay. No worries. Take your time.
Thank you.
So in the meanwhile, I would like
Hello, can you see my screen?
yes, perfect. We can see your screen.
Okay, great.
Yeah.
Today I'm going to present application of cleaner energy to enhance oil production using magnets and nanoparticles at optimum concentration. This work is already published from Journal of Cleaner Production, impact factor 7.24. Before I'm going to start, I'm going to give small introduction about myself. Actually, I'm in my final stage of my thesis. I'm going to submit my thesis next month. It's all about using electricity to alter and control waterability of hydrocarbon reservoir to favorable waterability using electrical power. I worked also in Halliburton, oil and gas, and I worked in Abengoa as technical engineer. So our agenda for today, small introduction, the research objectives, materials and methods, then move to results and discussion, the mechanisms, potential implications of proposed theory and findings into practice of cleaner production, means using solutions related to cleaner production, references and conclusion. As you know, carbonate reservoirs hold more than 60% of hydrocarbon worldwide, and there are several conventional techniques used to extract hydrocarbon. However, they are limited in performance and negative impact to the environment, and they are very costly. There are also research related to seawater and nanoparticles, which have great impact in increasing oil production. Recent research regarding using magnets or magnetic field also proved it has great impact on physiochemical properties presented by surface tension, pH, and contact angle. Also, the surface charge of the rock presented by zeta potential. So it's an alternative to conventional techniques. So our aim is to combine seawater, magnets, and nanoparticles, but mostly is to reduce the nanoparticle concentration and less damage to the reservoir with cost saving for oil and gas companies. Our objective is so easy, like cover research gaps. Research gaps, most of the research are related on sandstone reservoirs, a higher concentration of nanoparticles, lack understanding of mechanisms, and no field application of the technique. In addition to that, lack of detailed laboratory experiments. So we try to cover that. Materials used, they are displayed in table 1 and table 2. So we have our model oil to make the surface more hydrophobic using NDK with 0.01 molar concentration of stearic acid because the rock is initially water wet. It's outcrop rock from Austin chalk. So we make the surface hydrophobic. And the table 2 presents core properties. I presented just oil wet samples because I did studies on water wet and oil wet samples. Here, like it shows here the diameter, length, dry weight, porosity. In next slides, I'm going to present how we can get those values. So for core preparation, you can see from the right hand, core flooding machine, Vinci brand, and vacuum saturator, the same brand. So first we receive rock samples, we drill them according to the diameter of your core holder, either 1 inch or 1.5 inch. For my case is 1 inch. You trim them to the required length. For my case is approximately 7 centimeter. You clean them in following 48 hours and you dry them using desiccator. But for toluene is it's very dangerous chemical component. So all the process of cleaning should be under vacuum and covered. You measure the diameter, length, you take 3 measurements each and you average them. You dry weight also. Then you put the sample in the vacuum saturated to remove any presence of air and under 500 psi to saturated 100% water. I use ionized water in my saturation. Some people can use brine, so it depends the process. And then weighted weight is measured. After that, the sample is introduced quickly to the core holder. And in that case, you enter inputs, diameter, length, dry weight, and weighted weight, so you can get your porosity and the pore volume of your rock. Also, the permeability of the sample can be measured by injecting the water after removing any presence of air, a little bit injection of water to be sure there is no presence of air, because you remove the sample, the time you remove the sample from vacuum saturator, you introduce it to the core holder, there are some air bubbles. Then water, you measure the permeability to water, then after that you inject the model oil to make the surface hydrophobic. You inject model oil, then you get water saturation, is the water remaining in the rock, the rest is oil. After that, the sample is aged using aging cell for 1 month and 40 degrees Celsius using model oil. For pellets preparation, after the spontaneous imbibition, the rocks are dried and crushed, then sieved using American Petroleum Institute sieves. You take one gram of powder, then you put it in hydraulic press equipment under 9 tons for 150 seconds to get uniform pellets. For uniformity, then pellets are prepared just as it shown in this screen. For contact angle measurements, I used cheaper technique using the dog tin box. So it's cut 1/3. Then there is a magnetic belt on the ground of the cup, surrounded with 16 magnets. Sometimes each magnet strength is 3,000 Gauss, 3,000 times 16, or 6,000 Gauss times 16. So 2 magnetic belts use it separately. No modification on the equipment, just this kind. For spontaneous imbibition, this is the amode cell, and it's surrounded with magnetic belt. However, for spontaneous imbibition, 27 magnets are introduced. It means 27 magnets. It shows 6 kg, means 6,000 Gauss strength of each magnet. So times 27 is the total magnetic field. The same for 3,000 Gauss. Here the dimensions given between the rock and. However, the rock should be inclined to allow the imbibition of the water to push the oil. If it's standing like that, there is a blockage for water flow inside the sample. The results from effect of magnets on contact angle. Here the blue dots are presenting the magnet, 16 magnets, and each strand is 6,000 Gauss, as I explained previously. So adding the strand, the time is shortened. Here is 17 minutes, and here is the summary. I will explain it. 17 minutes, and this is maybe 32, and here is 51 minutes. So increasing the strength make the imbibition time shorter. What does mean imbibition time shorter? It means the water takes shorter time to enter the rock and push the oil towards production. Also, it means like shorter time required to change the surface charge of the rock, shorter time required to change the contact angle, allowing the water imbibition. And here I presented just the neutral, means 90 degree, which is neutral wetness, because you have water wet, neutral, and oil wet. And here is the summary. So without magnetic field, the time is longer to reach 90 degrees, approximately is 51. And for 30,000 times 16 magnetic field, it takes 32. And for last one, 6,000 Gauss, it takes only 17 minutes. Time becomes shorter. Effect of magnets and nanoparticles on contact angle means adding nanoparticles to in the presence of magnetic field. In piping fluid is nanoparticles, suspension in ionized water in presence of magnets, and in presence of magnets. So for core 5 and core 6, I forgot to mention in table 2, presenting alumina suspended in ionized water for core 5 in presence of magnets. Core 6 is alumina suspended, means mixed in seawater in presence of magnets. Core 7 is iron oxide mixed in ionized water in presence of magnets. Core 8 is iron oxide mixed in seawater in presence of magnets. There is one thing to mention, those nanoparticles are two types. Magnetic nanoparticles present by iron oxide. Iron oxide has high capacity of magnetization, and alumina nanoparticles isn't magnetized nanoparticles. So we see how this difference in magnetization can affect water-based alteration and other parameters. So we see here there is obvious change or significant change in contact angle from oil wet. This is initial contact angle 123, almost 124, without imbibition. Means after aging, you dry the sample, that's it, without putting the sample in under imbibition. But for core 5, nanoparticles, first one is without nanoparticles. Core 5, nanoparticles alumina mixed in ionized water in presence of magnetic field, contact angle reduced from 124 to 55.3. Core 6, because of salinity, it's 55.7, a little bit of difference. And core 7, core 8 is more reduction. This is because can be explained by the fact that destroying pressure is initiated and allowing desorption of carboxylic group or oil droplets production. So this, as soon as the wedge film starts to increase, I'm going to explain those wedge film, those parameters when we reach the mechanism. And more reduction is observed with iron oxide nanoparticles because of difference in magnetization effect, and is what we are going to prove in oil production or recovery assessment in the next slide. Here, the results from core 5 and core 6. This is A is when alumina is mixed in ionized water. Core 5, this is core 6, alumina mixed in seawater. Increasing the concentration of nanoparticles, obviously there is increase in oil production, but more increase can cause external layer to the rock to the reservoir rock and hinders the penetration of nanoparticles inside. Means hinders the role of nanoparticles in altering the contact angle and the surface charge of the rock. So optimal concentration should be defined in that case. And more increase in oil production is when nanoparticles is mixed in ionized water without effect of magnets. And here less production when nanoparticles presented in seawater. This is because of precipitation reaction between ions present in the brine and ionized nanoparticles makes nanoparticle precipitates and makes external layer as bridge. Effect of iron oxide. So similar process increasing here. Just forgot to mention, there is no effect of magnets added after nanoparticles. There is no effect, and there is no effect of magnets here, and there is no effect of magnets here. No matter where the medium of suspension, either ionized water or seawater, because alumina is non-magnetized nanoparticle. For iron oxide, the same observation, higher oil recovery is observed with ionized water compared to when iron oxide is mixed in seawater. And however, there is effect of magnetic field here. Adding magnetic field increase oil production further. This is what we explained. This because of difference in magnetization characteristics between the two nanoparticles. One of them is magnetized iron oxide, and alumina is non-magnetized nanoparticle. Even though without magnetic field, iron oxide showed better performance than alumina. Here's summary of oil production or oil recovery, and for alumina, there is no effect of magnetic field and high performance from iron oxide. Those results are from spontaneous imbibition. They can be higher if forced imbibition or effect of temperature is increased added to the system will make the production much higher because temperature enhances absorption of ions present in seawater and means better imbibition. For the mechanisms, this is proposed mechanisms based on our laboratory results and previous research. When I presented here only the seawater, I didn't present the ionized water things because of the time limitation for the presentation. So just I presented seawater, which is the main focus, as if you can take into consideration prepared ionized water is mostly more expensive, because imagine how many thousands of gallons you are going to inject into reservoirs. So you need water treatment station, all this to reach this level of ionized water. So here, when we have seawater, you see here potential determining ions presented by calcium, sulfate, and magnesium. So seawater has those potential determining ions. Those potential determining ions absorbs on the surface, making the surface, and dissolves, means they take sites on the rock surface, absorbs on that, and dissolves the carboxylic group, which causes the increase in the wedge film, which is between the droplet and the rock surface. Of course, because also this drowning pressure will increase. And here are the nanoparticles. Here I showed effect of suspension, nanoparticle suspension. Of course, there is slight increase, seawater plus nanoparticles. If we saw for both alumina and iron oxide, there is slight increase in oil production. So there is slight increase in the wedge film compared to seawater only. This is precipitation is caused, as I mentioned before, because of the interaction of the ions. Adding magnetic field will make better suspension of nanoparticles, better absorption of nanoparticles into the rock surface. Better invasion means nanoparticles can play effect of altering the waterability and the surface charge of the rock presents by zeta potential, which I didn't present here. The wedge film is much higher. Also, there is a coagulation effect because of the magnets, making the droplets become bigger and flow much easily. Another new parameter was introduced in this research, which hasn't discussed from any previous research, which is delta parameter, means relating the disjoint pressure with production rate. What does mean faster imbibition other magnets? Means time to remove all droplet from the rock is shorter without effect of magnets. So if I relate, or in another thing, you can describe it as the time required to remove all droplet from the initial time with the final time, means before introducing enhanced oil recovery technique and after introducing it makes the imbibition much faster. Here delta T for faster means shorter time required to increase the wedge firm, shorter time required and highest shorter time and a greater increase in wedge firm, and shorter time to change the surface charge of the rock, and shorter time to change contact angle, so shorter time for water to imbibe inside the rock. However, more research is required regarding this parameter, like advanced cameras in the lab and observe all the droplets, so it's more research on that. So delta T for water flooding is just normal water, it's the longest one. Formation time, there is high salinity, means it's a little bit, because high salinity won't play a good role in changing the physiochemical properties. So making seawater or low salinity water make the time shorter. Adding magnets make the time more shorter, and adding nanoparticles, time becomes more shorter. And this is first time for field application using either magnetic field alone, means this schematic can be applied only for magnetic field as it can be applied for hybrid technique. If I don't want hybrid technique, just eliminate the nanoparticles tank and follow the same system, then it becomes just seawater, magnetized seawater. So the best way to make this technique in the field is by installing magnetic belt or magnets around pay zone near the perforation without blocking the perforations. And this can be assisted from the surface by magnetic field generator to allow magnetization, pre-magnetization of your seawater or your imbibing fluid before it invades the formation, and also to keep the magnetization characteristics prior to injection downhole. And pre-magnetization means pre-change of zeta value or surface charge of the rock, pre-change of the contact angle, allowing better penetration of nanoparticles, which I didn't present here in our slides. The pre-magnetization, when magnetic field added at the beginning, it yields high performance, higher oil recovery, but low performance from the nanoparticles. So just here I showed how the optimum concentration is chosen. And the flow direction is mentioned here all around. It can be installed all around magnets like magnetic band or from this tank, but it should be very expensive. So the best way is magnetic field generator and magnets or magnetic belt around the pay zone. Here references used. For our conclusion, this technique, either magnet or hybrid technique using magnet with nanoparticles, reduces high concentration of nanoparticles. How? Because previous research used 40 times for iron oxide highest concentration than the one I used, and for alumina 5 times higher. Means this with the way I made laboratory experiments is a novelty, and reducing these concentrations allowing all fleet or oil and gas companies save cost and less damage to the reservoir, which we want, of course. And it's eco-friendly. Iron oxide proved the best candidate for Austin chalk in increasing oil production. A new parameter was introduced in this research to assess for explain relationship between disjoint pressure and production rate. Thank you very much for listening.
Hello.
Yes, thank you
Hello.
very, yeah, thank you
Oh,
very, thank you very
thank
much,
you.
Dr. Farida, for your nice presentation.
Thank you.
I would like to ask the participants, do you have any queries to Dr. Farida Amrochi? You can approach her now, or you can post your queries in the open chat box available at the bottom. Okay, it seems there are no queries. I would like to thank you again, Dr. Farida, for your wonderful presentation.
You are most welcome. Thank
Yeah,
you.
yeah, thank you. And now, Dr. Soumya Sobri, are you online with us?
Yes, I'm here.
Oh, yeah, okay.
Hi.
Yeah, you're able to share your screen, right? Yeah, hopefully. Thank you. So I have on your
Yes, thank
PPT.
you.
Yeah, okay. Okay, you can begin your presentation now. No worries.
Can I start? Yeah. Thank you.
So
Okay, thank you.
yeah.
I'd like to introduce myself. At the moment, I've been working as a postdoc researcher, and my voice. Can I continue my voice?
Oh, hello. Oh, hello, Dr. Soumya. We can hear some sort of noise or interference
Yeah,
from.
I'm here.
Yes, but we cannot hear you very perfect. So I would like to apologize to all the participants due to technical issues. So this is always common in a webinar. So we face a lot of technical issues here.
Hi, I'm here. Do you have my voice? Is it okay?
Yes, it is okay right now. So when you finish your current slide, you can say it next so that we can move the next slide. Okay.
Okay, thank you.
Uh,
Thank you.
but I would like to say that your audio connection.
Okay, I'd like to talk about magnetic connection. Magnetic connection is one. Do you have my voice or?
Yes, we can hear your voice, but it is breaking. Yeah, it is. It is breaking, so that we cannot catch you in the middle. Well, oh, hello.
Oh, no, I don't know. Okay. Magnetic connection. Oh, I'm sorry. Is it okay now, or can I continue, or you don't have my voice?
Yes. Now it is better. It is better now.
Thank you. Is important for plasma, especially space plasmas. It was originally curious as a way to power a storm sun, Here, I'd like to talk about it. There are various open questions in solar physics, and magnetic connection is one significant candidate to answer. We noted that different observational studies have shown. No, okay, can I continue, or you don't? It's better. Okay, thank you. Magnetic connection is one of important phenomena in plasma, especially space plasmas. It was originally characterized as a way to power storms and flares in space plasma, and especially on the sun. Through the atmosphere of the sun. And I want to talk about it in brief and describe magnetic connection. And after that, I show a picture that defines that magnetic connection, magnetic connection, and finally, summary. Slide. The next slide. Can you? Do you have my voice or?
Yeah, we can hear you, but your voice is okay. I would like to move on with the next presenter if you're okay with that. Meanwhile, you can check the technical issues working with the Zoom. Okay. So
Okay.
yeah, okay. So I would like to move on with the next presenters.
I'm sorry. Okay,
Yes.
thank you.
Yeah, yeah. Can you, in the meanwhile, please check your microphone settings because your voice is breaking in the middle, and we are facing some sort of interference, so that we cannot catch you in the middle. Yeah. Okay. Okay. No worries.
Okay. Okay.
Yeah.
Okay.
No worries.
I check it.
Yeah. So I would like to go for the next presenter, Dr. Ayat Allah. Are you ready to present now?
Yes. Hello, everyone.
Yeah. Hello. Okay. So let's check.
I have to share my screen, right?
Yeah. Okay. So before that, I would like to give a small intro about you. So, and after that, you can start your presentation.
Okay.
Yeah. Dr. Ayat Allah Baumandai completed her engineer's degree in energy at the School of Energy Engineering of the International University of Rabat in 2017 in Morocco, with thesis on the implementation of different structure of hybrid systems in different regions of Morocco at the Green Energy Park platform of the Research Institute for Solar Energy and New Energies. In 2016, Ayat Allah had the opportunity to participate in an exchange program where she spent 6 months at the European School of Materials Engineering and National School of Electricity and Mechanics of the University of Lorraine in Nancy, France. Then in 2018, Ayatollah completed her master's in energy and environment science, technology, and management at École Polytechnique in Paris, France, with a thesis on the operation of photovoltaic power plants, data processing and analysis, modeling, and force diagnosis at GEEPS Group of Electrical Engineering, Paris of Centrale Sapilec. Dr. Ayatollah, you're most welcome to begin your presentation now. Thank you.
Yeah, thank you. So yes, I'm Ayat Labarmdan. I'm a PhD student. I'm currently a PhD student at the Laboratoire de Météorologie Dynamique of École Polytechnique. So I would like to thank all the organizers for inviting me to this conference to talk about my work on the sensitivity of the American mix to the integration of CSP with thermal storage and battery storage combined with PV. By analyzing the response of the optimal mix to storage to the difference of between this two solar technology in terms of storage and cost. So first, I will start by presenting the context and the research question that this study aims to answer. Then I will give an overview of our objectives and the methodology adapted. Then the resulted scenario of optimal mix, and finally I will provide some implication and my ongoing work. So as we know, currently there are, I will have just to skip this. So currently, with growing concern on climate change, some countries are trying to reduce their greenhouse gas emission. So as stated by the fifth assessment reports working on the climate mitigation, that the emission scenario making possible to limit the global warming to 2 degrees is characterized by a reduction of greenhouse gases by 40 to 70% by 2050 compared to 2010, and this emission should be close to or below zero by 2100. So to achieve this goal, the share of renewable energy must exceed 50% by 2050 for the total final energy consumption and 80% for the electricity supply. Currently, the share of renewable energy has only seen a moderate increase. So as of 2018, it's accounted only for 11% of the total final energy consumption. And overall installed capacity was enough to provide 27% of the global electricity production. The highest share is in the power, the highest share of renewable energy is in the power sectors, but this sector only accounts for 17% of the total final energy consumption. The transport sector represents 32% of the total final energy consumption, but it has the lowest share of renewable energy. And the remaining thermal sector represents more than half of the total final energy consumption, where only 10% was supplied by renewable energy. So one option to reduce the climate change is to use renewable energy like wind or solar technology, solar technologies like CSP and PV. So focusing only on solar technologies, they are both collecting solar radiation and producing electricity, but they do so through different costs and variability. So before discussing the difference between the cost and variability, the conversion of energy between these differ between these two technologies. For example, CSP require power block to convert the thermal energy provided by the solar field or by the thermal energy storage to electrical energy, and PV requires an inverter to convert the DC energy provided by the solar panel or by the battery energy storage to alternative energy. The solar energy, the solar resource that both technology use is also different. CSP only use the direct solar radiation, which make it more sensitive to clouds and aerosols in the atmospheres, and this limits the installation of CSP only in region with minimum cloud cover and maximum solar radiation and temperature to increase the CSP efficiency and to be economic. PV, on the other hand, use both the direct and the diffuse solar radiation, so the global horizontal irradiation. So it is less sensitive to clouds like CSP, but high temperature and low irradiation intensity reduce the PV module intensity. And in general, the distribution of temperature and the one of the global horizontal irradiation is not the same. For instance, places where we can have low solar resources may benefit from cooler air temperature, which increase the PV power output, while places with higher solar resource may hinder the PV power outputs just because they have higher temperature. So in general, PV can be installed everywhere, not like CSP. The variability and the risk of not covering the load also is different. So here I represent the CSP capacity factor and PV capacity factor over 2 consecutive days. So as we can see, PV and CSP without storage, so what I represent here in gray, they can only produce electricity when the solar radiation is available. So the fact that so it's like they have an SM1 or for PV in solar multiple 1 or inverter loading ratio ELR 1 for PV means that the solar field, the CSP solar field is or the PV solar panels are just large enough to drive the turbine or the inverter at nominal capacity only under nominal conditions. So for example, at noon, when the solar radiation is at the maximum. The fact that these technologies without storage are linked to the temporal availability of solar radiation lead to an oversupply during midday and shortage of electricity after sunset when the PV or CSP production drops. So this can lead to increase the integration costs because we need other sources to meet the mismatch between the production and the consumption. And this also affects the profitability of the conventional production. Increasing the hours of operation involves increasing the solar multiple, which is the additional solar field and the thermal storage capacity, or the solar panels and the battery storage required to produce also when the sun is not shining. So this ability to so here more the storage is increased, more we can shift energy over time. So this dispatchability or ability to produce at any time can reduce the integration cost. So it's like to reduce the cost and emission resulted from satisfying the mismatch that can be provided by, for example, conventional production like gas or coal. Increasing the hours of operation, it's not only the variability that is decreased, but also the capacity factor and the costs are increased. So here we can see the impact of increasing the solar multiple, increasing the solar field size, and the hours of storage, so the storage capacity, thermal storage capacity on the CSP capacity factor. What we can see is that the capacity factor increase even without storage. This is because the CSP with NSM1 rarely produce at nominal capacity, and increasing the SM while also increasing the storage duration allows higher capacity factor to be achieved. Here we represent the same impacts, but on the levelized cost of electricity. So it's the discounted cost divided by the discounted production over the cycle, the life cycle of the plant. What we can see is that from SM1 and SM1.5, the levelized cost is decreased for low level of storage duration, but increasing the SM and also increasing the hours of storage helps to decrease the levelized cost of electricity. So the most conclusion to emerge from these two figures is that there is no linear relationship between the capacity factor and the cost. So in this study, we try to analyze the sensitivity of the optimal mix to cost and storage associated with PV without and with battery and CSP with and without thermal energy storage under different penetration scenarios. First, we consider only the integration of CSP with different SM, so different storage duration, with PV without storage and wind, and then we add the battery to see the effect of the battery on the optimal mix. So our objective is to maximize the renewable penetration, so the renewable production over the demand, and minimize the variability by taking in, by considering three strategy, either global strategy where we aim to minimize the total variability of the whole country, so by taking into account correlation between technology and region. Strategy where the technology strategy where only the correlation between technology of the same region are taken into account, and base strategy where all the correlation are ignored. So this mean variance optimization problem is implemented in the IFAR-CLIM model, where we consider Morocco as case study. We model the electricity consumption, the wind production, and the solar PV and CSP with both without and with different storage duration. Then we optimize the technological distribution, means for given penetration, how much wind, PV, CSP, PV with storage, CSP with storage should be installed and where, by optimizing also the geographical distribution. So since here the variance as defined in the optimization problem is only an aggregate measure of the variability, it does not take into account the specific time when there is fluctuation between the production and the consumption. We add some diagnostics after the optimization based on, for example, the capacity credit to see the contribution of each technology on increasing the capacity credit, so on reducing the peak load demand. So this gives more detailed analysis of the services that each renewable technology provide to the system. So instead of minimizing only the variance or minimizing only the cost, we take the mean and variance as proxy of the system adequacy risk, and we take as constraints the maximum cost constraints, means that the total cost of the optimized capacity should not exceed the total cost of the actual renewable capacity installed in Morocco. So here the total cost is the capacity multiplied by the yearly rental cost. After the bias correction of the capacity factor, we get constant capacity factor of CSP and PV for different SM and ELR. This is because for CSP, all the operational power plants that are operational in Morocco, by which we correct bias in the capacity factors, have constant SM, even though they have different amounts of storage. And for PV, all the plants that are installed in Morocco and considered for the bias correction are without storage. So this brings the capacity factor to similar value for all the SM and ELR. So for this reason, we consider that the cost of solar field that increase with increasing the SM, or the cost of the solar panel that increase with the increase of the ELR is constant. But for the cost of storage, we consider three cases. Why we consider three cases? This is because in the literature, they say that, and also the cost data, we find that PV has low cost but CSP is expensive. But the battery that is commonly used with the PV is expensive, while thermal energy storage, which is in general combined with CSP, is cheap. So we consider three cases. The first case is that we vary the cost of storage as function of the SM and ELR, so as function of the storage capacity. And a second case where we ignore the storage costs to see if the fact that we ignore the cost of thermal energy storage, which is cheap compared to the battery, affects the results. And the third case that we take into account implicitly the cost of storage, which corresponds to the plants, which is mostly, which is widely deployed. It's CSP with 6 to 8 hours on average. So we get as solution the mean penetration as function of the renewable variability, which is the standard deviation of the renewable outputs. And here is the average of the renewable production. So the advantage of the mean variance optimization problem is that we don't get one optimal mix, but several mixes ranging from minimum penetration and minimum variability to maximum penetration and maximum variability. So each point here are Pareto optimal, means that we can't increase the penetration without increasing the variability, and we can't reduce the variability without reducing the mean penetration. The mixes that are in the white region here are suboptimal, means that, for example, here the point B, higher penetration can be achieved for the same variability, or lower variability can be achieved for the same penetration. And mixes here are not, are by definition not feasible. So for each level of penetration, we can represent the technology fraction of PV, wind, and CSP. So here we consider three regimes. The one where the maximum at the maximum penetration mix. So the technology that is installed is only one capacity in one region that maximize this ratio. So more this ratio is high, more we spend less to install large capacity. So the technology that should be installed should have lower low costs and high capacity factor. When we decrease the level of penetration while the cost constraints remain active, the covariance, in addition to the capacity factor and the cost, play a role. So the technology that minimize this ratio, so it's that have lower correlation with the technology which is already installed, and which also has high capacity factor compared to costs, so also large maximum penetration ratio. When we continue to decrease the penetration after until the cost constraint is not active, so we install all the capacity in proportional way to the minimum variance ratio, because at low penetration there is only little capacity that should be installed, so the costs do not play a significant role in determining which technology should be installed. So as a result, we consider different combination. We start by only PV without storage and wind. Then we add CSP without storage. Then we add CSP with storage and increase the SM, increase the solar field size. And for each of these 6 combination, we add the PV battery. So here, for example, for PV wind, we add PV ELR2, ELR3, ELR4. For the combination with SM1, here PV ELR2, ELR3, ELR4, and for all the 6 combination. So what we represent here is in ordinates the technology fraction, and in abscissa the mean penetration. The blue line is the wind share. The brown line is the PV share, and orange line is the CSP without or with storage share. The crosses are the technology fraction of the wind, PV, and CSP for the actual mix, and this dashed vertical line is the penetration with the largest mean penetration before the activation of the cost constraint. So the main results is that the technology share are constant with the mean penetration at low penetration before the activation of the cost constraint, and then beyond this level of penetration, which we call the economic carrying capacity, which is the level of penetration at which the cost outweighs the benefits of installing the storage. So when beyond this level, it's the technology share either increase or decrease. So this means that the optimal mix are only sensitive to costs at high penetration, and more we add CSP and more we add CSP with storage, more the mix become sensitive to costs. And the same when we add the PV battery, more the ELR increase, more the storage increase, more the mix becomes sensitive to cost, which proves the strong sensitivity of the optimal mix to storage costs. Focusing only on the point maximizing the penetration, so we can see that for all combination, wind gains a higher share than PV or CSP for all the combination. This is because we found that in Morocco, the best trade-off between more electricity production per megawatt installed and lower yearly rental costs is achieved by wind. So that's why wind installed here in the points maximizing the mean penetration. When we start to decrease the penetration, it is always wind, but for the maximum penetration, it was installed in the east of Morocco. And when we decrease the penetration, it is installed in the south. But we can see here that after when we start to decrease the penetration, PV is always introduced in this intermediate level of penetration. This is because there is a low correlation between the wind and the PV in Morocco, and also because the PV has high capacity factor compared to its costs. But when we add the PV battery, there is always dominant technology, either PV battery or CSP with storage. So for example, here we don't have CSP, so it is always PV. But for combination with CSP SM1, the CSP tends to replace the PV plus battery because the CSP SM1 costs less than PV for all the ELR. For combination with SM2 and SM3, with ELR2 is the PV because PV costs less than SM2 and SM3, but increasing the ELR to 3, 4 favor the installation of CSP than PV because the cost of CSP SM2 and SM3 is less than the cost of PV ELR3 and ELR4. At low penetration, where only the capacity factor and variance play a role, different combination lead to difference in the sensitivity of the minimum variance ratio. So comparing the PV and wind, the wind is installed more than PV because wind is less variable than PV because it is less tightly coupled with the daily and seasonal cycle like PV. PV, for example, it is affected by clouds during the day and also by the day and night alternation. So we can't produce after sunset. And also its capacity factor decrease during summer when the temperature increase. but the wind is evenly distributed over the year and over the day. Even it is also variable, but less than PV. Comparing PV and CSP both without storage, it's the PV that is installed because the fact that PV use the direct radiation and diffuse radiation make it less variable than CSP. Even CSP is not sensitive to temperature like PV, and even CSP use tracking. But when we add the storage to CSP, it makes the CSP less variable than PV, and CSP replace completely PV. And with increasing the storage, it tends also to replace the wind. Between PV with storage and wind, more the ELR increase, more the PV with battery becomes less sensitive, becomes less variable than wind, and it is installed more than wind. Comparing PV with storage and CSP or CSP with storage for the same design, for example, ELR2 and SM2 and ELR3, SM3, ELR4 and ELR SM4, it's the CSP that is installed. So CSP is less variable than PV for the same design, because we found that the CSP with storage contributes to reduce the peak load hours more than PV with storage. But for different design, for example, ELR3 and SM2, the technology with higher storage duration, it is installed more than the other technology. For example, here ELR3, SM2, or for example, SM3, ELR2 is the CSP. For example, here it is PV because ELR3. For example, here PV, ELR4 and CSP SM3, so it's PV. So this is the results of the integration of the impacts of only CSP and CSP with storage, and here the impacts of the addition of the battery to PV. So as implication of this study is that the implementation of PV and CSP is widely suggested within the Moroccan energy strategy, but the share of between PV and CSP and amount of storage associated with this two solar technology is not defined. The strategy aims to deploy 20% of its electrical capacity from solar energy, but there is no clear definition of the best split between PV and CSP and how much we should install of storage for both. So actually, I'm trying to implement this modeling framework in future climate to assess the impact of climate change on the optimal mix and the role of the flexibility of PV with battery and CSP with thermal storage in reducing the climate sensitivity. So thank you for your attention, and here is my references.
Thank you very much, Dr. Atala, for your nice presentation. In fact, you have presented last time at the Geological and Environmental Sustainability webinar, and I'm very glad to see you here as well. Thank you again for joining this Renewable Energy Source Conference as well. Thank you so much.
Thank you. Thank you for it.
Yeah, so and it's time for the audience. Do you have any queries to discuss with Dr. Ayatollah? You're most welcome, so that she will be able to answer your queries.
Yes.
Or So if you want to discuss any queries to our email or not to be discussed here, you can contact her via email. You can see her email on the screen. So you
Yes,
can
of
have
course.
you can have a snapshot or screenshot of that, and so that you can approach her after this webinar for any queries. Okay, it seems there are no queries. Thank you once again, Dr. Ayatollah, for your time.
Thank you.
Yeah, thank you so much.
I will stop the sharing.
Yeah. And I would like to request now Dr. Somay Sabri. Are you? I think your audio connection is perfect right now.
Yes, I think that it's okay now, but I don't know. Do you have my voice? All right.
Yes, it's very perfect now.
Okay, thank you. Can I start?
Yes, you can start now. You can start now.
Okay, thank you. Magnetic reconnection is one of important phenomena in plasma, especially space plasmas. It was originally recognized as a way to power storms, flares, and other phenomena like solar winds and etc. Then I'd like to talk about it. Because it's so important in solar physics, and most of the studies have shown magnetic connection in solar atmosphere. I like to talk about it at first, and after that I want to have a brief description of magnetic connection, and also show a picture that defines that magnetic connection is important through the universe, not only in solar atmosphere. And we have a characteristic of magnetic connection, and finally we have the summary of the this presentation. Please go for next slide if it's possible. Thank you. We know that energy source of the sun locates at this core of the sun. Nuclear fusion happens at the core, and it's expected that with the distance from the core, temperature would be decreased. And so the photosphere of the sun, it is true. And temperature decreases with the distance from the core. But through the, please go for next slide. But through the chromosphere, as it is clear in this picture, temperature increase, and yes, next slide. And in corona, the one of the layer of the sun, we see that it's something strange happens, and the temperature is so higher than the first layers of the sun. And it is one of the important questions of the sun, that what happened in these layers that it leads to the high temperature of the plasma in these layers. And magnetic reconnection is a main candidate of this event, and also different observational studies shown that it happens in solar atmosphere. Please go for next slide. Yeah. We have here we have different layers of the sun: core, radiative zone, and convection zone. And finally, the atmosphere of the sun, that includes photosphere, chromosphere, and corona. Magnetic reconnection in solar atmosphere, in the outer layers of the sun, lead to the solar flares or solar winds. That here we have some important outcome of these events. Amount of the energy which releases through the reconnection is so high, is around 10 to 31 Hertz. And it happens almost very fast, 10 to 4 seconds, and it took 10 to 4 kilometer area. And it also results in particle acceleration or solar wind that impress our life on Earth. Please next slide. Yeah, here we have a schematic figure of the flares. We have a flux tube at first layer flux tube, and also that plasma confined that area, and we have magnetic field lines, and the point that magnetic connection happens and energy releases. Please next slide. Yeah. Through the different observational studies, it's found that there are a lot of magnetic null points in solar atmosphere. Here we have an X point that magnetic field is zero at the origin, and reconnection happens around that point. And we called this structure as X point, or X point that includes a magnetic null point at the origin of the structure. Please next slide. And then I want to describe a magnetic connection in a very simple way. When two magnetic field lines approach very close to each other, as we see in A panel, in a limited area, these field lines approach each other, and magnetic connection happens, and magnetic structure changes, and it accompanies by magnetic energy release, particle acceleration, plasma heating, CME, that spread along the space and also impress terrestrial life. Please next slide. I have an animation of my work here. I don't want to focus on my study because I think that it would be boring. I have to just one slide that show how magnetic connection happens in solar coronal condition. Please play this movie. We introduce a background X point with considering other parameters of solar coronal condition. Could you please play the movie of the previous slide? Yeah, it's a movie. No, next slide. Yeah, this is a movie. If you share my PPT. No, I think that it's my PDF file, yeah, not PPT file. Okay, and in previous slide, I put a animation that it's an animation, and you can. Okay, with considering the parameters of the solar coronal condition, we numerically study magnetic connection in solar coronal condition, and after some time during my simulation time, reconnection starts happen, and it results in some interesting outcomes. That it's a movie. Yeah, here we have frequent reconnection. And it's so important in plasma, and finally we have plasmoids that results in high temperature of plasma that can answer the question of solar physics, that why the corona is so higher than the first layer of the sun, that it's they are near the core of the sun. And I don't want to focus on my study. I want to speak very general, that others don't be so tired. And please next slide. Yeah. Magnetic connection actually doesn't confine in the sun. We have this important event through the different area. At first picture, we have a sun and solar flares, that magnetic connection happens through the atmosphere of the sun. In the next picture, we have magnetosphere or the Earth, and we see that magnetic connection happens through our planet, also near our planet, and we have high magnetized star, and it's shown that magnetic conduction happens through that kind of stars that they have high magnetic field structure. And finally, we have magnetic connection in laboratory plasma, or called tokamaks. And it also it's so important and results in high temperature in that device that's so useful for some work. Please, next slide. Yeah, this is tokamak disruption that it happens in laboratory plasma, not in space plasma. Please, next slide, if it's possible. Yeah, it's tokamak in laboratory plasma. Please, next slide. Yeah. Yeah. Here we have a schematic figure of flares, and yeah. Here we have a picture that it is shown that magnetic connection happens through the universe besides the sun. And it must be noted that magnetic connection could explain high energy gamma ray emission from the center of the Crab Nebula. It's a picture of a Crab Nebula that it carries a lot of gamma ray, and magnetic connection could explain this event through that nebula. Please, next slide. Yeah, here we have a picture of tokamak. Then it means that the connection is so important besides the astrophysical application. And occurrence of magnetic connection in space plasma, it also happens in laboratory plasma. Tokamak is a device that we have a picture of it, which uses a powerful magnetic field to confine plasma in the shape of torus. And it's developed to produce controlled thermonuclear fusion power by magnetic connection, because magnetic connection is an event that releases a lot of magnetic energy into kinetic energy, and then it is useful in this kind of devices. Please, next slide. Yeah. As we said, we have magnetic connection in the Earth's magnetosphere. Our planet, because our planet has also magnetic field, the magnetosphere shields our home planet from solar and cosmic particle radiation. Besides, magnetic connection also happens through the Earth's magnetosphere. This event resolves some problems on our life, especially on our electronical devices. Then studying the connection and also prediction of the connection near our planet is so important, and we can protect our device from that damage. Please, next slide. Yeah, it's a picture of aurora that is so beautiful. Besides the drawbacks of reconnection in Earth's magnetosphere, it also results in some picturesque scene that we saw sometimes that happened because of the reconnection in magnetosphere of the Earth. Please, next slide. Yeah. Why is the connection important? Because it's a process, it's an important process in plasma that is capable of releasing large amounts of magnetic energy in a comparatively short time in plasma. And interestingly, it is an important event that explains some open questions in space plasma. Then it is so important in space plasma and also in laboratory plasma. If we can provide this situation, it could result in high energy releases, and it's so useful. Please, next slide. Yeah. Because of the general characteristics of magnetic connection, it generates an electric field which accelerates particles parallel to a magnetic field. It dissipates magnetic energy to kinetic energy, and it also accelerates plasma or converts magnetic energy into kinetic energy, and it also changes the magnetic field structures. And finally, the next slide summarize. The important events that happens because of the connection is solar flares that releases high energy around 10 to 31 ergs in a small time, around 10 to 4 seconds. So important events that results in CME and solar winds and affects our life on Earth. And also magnetic connection is a physical process in highly conducting plasma in which the magnetic topology is rearranged, as we said, and magnetic energy is converted to kinetic energy, thermal energy, and also we have particle acceleration. Then studying magnetic connection is so important, and it's a important event in plasma that accompanies with some important events such as heating and particle acceleration. Thank you, everyone.
Thank you very much, Dr. Samir Sabri, for your wonderful presentation.
Thank you.
Yeah, so it's time for the audience. So I'd like to request the participants, if you have any queries, you can approach Dr. Samir Sabri here, or you can type your queries in the open chat box available at the bottom.
Thank you.
Okay. Or else if there are no queries, we will move on to the next presenter. And I would like to thank you once again, Dr. Sabri, for your presentation as well.
Thank you. Welcome. Thank
Yeah,
you.
you're welcome. It's my pleasure. Yeah. Yeah, I would like to call upon to the next presenter, Dr. Alexandra Carolina. Alexandra V. Montana is a microbiologist from University at Antioquia, Colombia, with MSc in Agriculture Microbiology, University at Estado Polet, UNESP Brazil, and PhD in Sciences emphasized in Sanitary Engineering. She is currently a professor and researcher at Technological de Columbia. Her research experience has focused on topics related to biological production of hydrogen and methane, wastewater treatment, lignocellulosic waste, characterization of microbiomes using molecular tools, the microbiology of aerobic and anaerobic systems, and degradation of inhibitory and toxic compounds. Dr. Alexandra Villa, you're most welcome to begin your presentation when you're ready. Thank you.
Good afternoon. Can you see me?
Yes, we can see you.
On my screen.
Yes, we can. We are able to see your screen as well, and we can hear you very perfect.
Thank you. Good afternoon. I'm going to start with my presentation. My name is Alejandra Villa, and today I want to talk about this project titled Biohydrogen Production from Coffee Waste, Overcoming Challenges Through Bioprospecting, Pretreatment and Optimization. Is a project developed in the Universidad de Sao Paulo, Brazil. In Sao Paulo and in Brazil, the coffee post-harvest processing apply water to remove the husk, pulp, and mucilage from the coffee. This method is called wet coffee processing. And with this, it generates two important ways. First, a solid waste, pulp and husk, and the wastewater. with a high production of the waste. The pole and hose had a production between 8 and 12 tons per ton of coffee processed, and the wastewater between 5 and 15 thousands of liters of this water per ton of coffee processed, with several environmental problems such as salinization of the soil, water eutrophication. But this waste had high content of carbohydrates in the pole and hose, mainly cellulose and hemicellulose, and high organic matter in wastewater. And with this, it's possible produce other bioproducts, such as bioenergy, such as hydrogen, or ethanol, organic acids, or other products for industrial application or for the energy generation. This project had the objective of use this coffee waste to the production of biohydrogen. But first, several challenges need to be think before. For example, what is the best waste? The proposal here was the co-digestion of the wastewater, pole and hose, because it's possible to improve the substrate composition, their macro and micronutrients, alkalinity, pH, and with this improve the biohydrogen production. And other proposal was the pretreatment. The pretreatment of the pole and hose generate a solid fraction with high amount of cellulose, and with this is possible ferment these pole and hose and produce biohydrogen. What is the best inoculum? The proposal was screen microorganisms from the coffee waste, for example, bacteria, yeast, do it that the other previous research identifies several microorganisms in these ways. And with this is possible screen pathways for the hydrogen production and other interesting metabolic pathways. And screen a microbial consortium autochthonous from these ways for the fermentation. What are the best conditions for hydrogen production? The proposal was studied multifactorial experimental designs. First, a Plackett-Berman design to screen or study several factors at the same time with low experiments, such as agitation, nutrients, substrate concentration, bioaugmentation of this microbial community, pH, temperature, and other factors important for the hydrogen production. And later, with this rotational central composite design and response surface, identify the optimum condition of the maximal condition for the biohydrogen production. How to improve the hydrogen production? The idea was to study the DNA from the microbial community and identify through metagenomic analysis taxonomic structure, interesting microorganisms, genes, enzymes, metabolic pathways to offer increasing this hydrogen in the reactors. And with this, the objective of this study was to screen the factors that affect the hydrogen production from coffee waste, focusing on the bioprospection of a consortium of bacteria and fungi, selection of pretreatment condition in a hydrothermal reactor, optimization of hydrogen production, and taxonomic and functional characterization of the microbial community. The proposal was first screen this microbial community. For this, simulate the wet method of coffee processing here. And with these waste here, the pole, hose, and wastewater, start the fermentation in this condition, 35 degrees Celsius, pH 5, 3.5 grams of chemical oxygen demand per liter of wastewater, 2 grams per liter of polar host and 1 grams per liter of Jesus drug in this reactor, and increase the volume of the reactors from the reactor 1, 250 milliliters, and the last 2 liters, recovering the microorganisms or the biomass in a reactor for centrifugation or sedimentation. And with this last community, bioment the other experiments in this project. The waste was collected in the Lagoa farm in Sao Paulo, Pedregulho. This farm do this coffee processing of the grains using the wet method with 2.4 liters of water per 1 liter of coffee grains processed. And the water was collected here in this lake, and the solid waste coffee Poland host was collected here in these mountains. Daily, this farm generated 50,000 liters of water and 96,000 liters of solid waste. It's a huge waste generation to improve this methodology of biohydrogen production. Later, the Poland host was pre-treated in this reactor, the hydrothermal reactor, using 3 grams of Poland host per 200 of milliliters of water. The selection of the best conditions for hydrothermal pretreatment is not part of this presentation, but the condition selected was 180 degrees Celsius during 15 minutes. And with this, Poland host start the fermentation in the reactors. Later, apply plaquette Barman design for evaluate the fermentation factors during the coffee waste co-digestion. The idea was to study 8 factors here with 3 central points. The factors were pH between 4 and 7, temperature between 30 and 50 degrees, agitation between 0 and 180 revolutions per minute, headspace between 50 and 70% of this volume of the reactor or headspace, biomentation between 0 and 20% of the volume, pulp and host between 2 and 6 grams per liters, and wastewater between 7 and 30 grams or COD per liters, and Jex extract between 0 and 2 grams per liter. With these conditions, start the fermentation and evaluate the best or the reactors with high gas hydrogen production. Later, 3 factors were studied again, applying the rotational central composite designs and reinforced surface with the idea of optimize the hydrogen production or identify the maximal conditions or the condition for the maximal hydrogen production. Starting this matrix design with 3 factors, pH, headspace, pull and host, and 3 central points again. The idea was to study the pH between 4 and 8, headspace between 33 and 66, pull and host between 6 and 17, and the hydrogen in the reactor or the hydrogen accumulating in the reactor was studied or applied in this modified Gompers model for to identify the kinetic parameters such as the P or hydrogen production potential, Rm or hydrogen production rate, lambda time to start the hydrogen production, and with this later construct a mathematical model and a response surface to identify the maximal hydrogen production. Finally, the methodology collects samples from the microbial consortium, this first reactor, due to the hydrogen production. And samples from the plaquette Berman design, assay 9 and assay from the central points due to the lactic acid and ethanol production in this reactor. With these samples, the DNA was sequenced using metagenomic sequencing in the Illumina Nova-seq. And with this DNA sequencing, identified the taxonomic and functional structure in the microbial community. Using for taxonomy the REPSEF or NCBI reference sequence database, and for functional the KEGG or Kyoto Encyclopedia of Genes and Genomes. And with this propose metabolic pathways during this fermentation. Okay, here are the results. First, it was possible to identify microorganisms in this reactor from the screen of the microorganisms in the waste. In these reactors was identified hydrogen. The maximum hydrogen content was 150 milliliters of hydrogen without methane. And during the microscopy analysis was identified microorganisms such as Clostridium, Saccharomyces, and other interesting microorganisms with potential for the hydrogen production, ethanol production, and other interesting pathways for use these coffee waste. Later, during plaquette Berman design were studied the 8 factors in the table here. Was identified hydrogen production in some reactors. The maximum hydrogen production was in the assay 1 with 82 milliliters of hydrogen. The statistical analysis identified the most important factors in the fermentation, factors in the fermentation were pH, temperature, and headspace volume. With a pH near to 7, how the factor that improved the hydrogen production, mesophilic temperature too, and low headspace volume. These factors improve the hydrogen production in these conditions, and these other factors for these factors were identified the conditions, the better conditions for the hydrogen production here. In these reactors was studied the different organic acids and alcohols production. Was interested in identify here in the assay 9 in green lactic acid production of 15% in condition of pH 4 and 30 degrees due to microorganisms such as Lactobacillus kazakhstania, this is a yeast, with a metabolic potential for lactic acid production, ethanol production, hydrolysis, and other pathways. And this assays of central points was interesting seeing identified in yellow here. Ethanol production near to 37%, that is other important product for energy generation in condition of pH 5.5 and 40 degrees. With microorganisms such as Clostridium, Lactobacillus, and Kazakhstanium. Clostridium is important microorganisms for the hydrogen production in anaerobic conditions with several pathways for hydrolysis, the pulp and host in these reactors. Later, using the DNA, the KEGG encyclopedia, and the taxonomic structure to metagenomic analysis was proposed this metabolic pathway in the reactors. In blue, the enzymes or genes identify the microbial consortium. In green, in assay 9, and in red, in assay of the central points. For this was important consider the waste composition, pectin, lignin, lignocellulose. And for this was interesting to identify enzymes such as the pectinoids for degradase this pectin, this polymeric pectin. Lignin and aceril-CoA aceryltransferase for degradate lignin in this pole and host. Endoglucanase and beta-glucosidase for degradate cellulose. And for the different components in the hemicellulose, enzymes such as the alpha-galactosidase, beta-galactosidase, and others, several enzymes in this reactor. Using or applying these enzymes, it's possible to obtain monosaccharides. And for several reactions, generate hydrogen using, for example, the flavonoxine oxidoreductase. Ethanol using the alcohol dehydrogenase. Lactic acid using IL or D, lactate dehydrogenase. And identifying the most important microorganism in this reactor, the Clostridium, because Clostridium develop reactions of hydrolysis or production of several compounds from the coffee waste. With the results of cumulative hydrogen in the reactors was identify or construct this model here for the hydrogen production. And with this model, construct this response surface. In red, it's possible to identify the regions of high-gas hydrogen production of the optimized conditions for hydrogen production. In pH between 6.5 and 7.5, Poland host between 6 and 9 grains per liter, and headspace volume between 30 and 35%. And in summary, during the Plackett-Berman design was to study 8 factors and identify better conditions for wastewater, temperature, agitation, bioaugmentation, and yeast extract. The other factors were studied again during the rotational central composite design and whisper surface, and identifying the optimal condition of pH, headspace, and pole and host. And with this, identifying the best conditions for 8 factors in total. The hydrogen potential increased from 82 to 240 milliliters of hydrogen is an increase of 300%. And the production rate increased from 4 to 90 milliliters of hydrogen per hour, with an increase of 455%. In conclusion, the walls from the coffee processing have native microorganisms, autochthonal microorganisms such as bacteria, fungi, with potential for the fermentation and the hydrogen production. The hydrothermal pretreatment modified the physical and chemical structure of the waste of the coffee pole and host, and with this improved the hydrogen production. The co-digestion of coffee waste, wastewater, pole and host increased the hydrogen production in the reactors. Changes in the physical-chemical factors during the fermentation increase the production of specific metabolites such as hydrogen, organic acids, alcohols, and modify the community structure. Hydrogen production can be optimized through the selection of fermentation conditions. These applied in multifactorial studies. And the microbial community and functional genes change due to the operational condition of the reactors with coffee waste. And with this I finish. First, I want to thank to the Resource Energy, Universidad de Sao Paulo, and Tecnológico de Antioquia for the financial support. and for this invitation. And here is possible search the articles for more information or write in my email. Thank you.
Thank you very much, Dr. Alexander, for your excellent presentation. So for speaking on biohydrogen product from coffee waste overcoming challenges. So it was very nice also, and I would like to go for the participants. Do you have any queries to Dr. Alexander so that she can answer your queries, or she displayed her email on the screen, so or else you can contact via email, so if you have any queries later as well.
Here my mail.
Any queries? So I can hear someone spoke here. So do you have any queries to discuss with Dr. Villa?
Yes, hello?
Yes,
hello?
Doctor.
Yes, please. This is Dr. Yahuza Ibrahim from Air Force Institute of Technology, Kaduna, Nigeria. I don't know, have you considered the amount of energy in changing the lignocellulose to cellulose? In converting the lignocellulose to cellulose?
I don't consider this. I just consider the breakdown of the coffee pulp and husk to increase with this hydrothermal retracement, this content of cellulose and hemicellulose.
So maybe in the further research is important because the amount of energy, we are conserving energy. And then I know lignocellulose, converting it to cellulose, it requires huge amount of energy from husk to the lignocellulose to the cellulose. It requires huge amount of energy. And then that energy, that is used in converting the lignocellulose to cellulose and various distance needs to be quantified.
Yes, I quantify the content of cellulose and hemicellulose, but it's a other article that I don't use for this presentation, but I quantify this cellulose and hemicellulose.
Lignocellulose to cellulose.
No, the cellulose and hemicellulose.
No, my concern is from the lignocellulose to cellulose. I think it's important to take note of it in the next research.
Okay. Thank you.
You're welcome.
Yeah, thank you very much for your response, Dr. Alexander, for the audience. So still any more queries, or else we will conclude the webinar within 5 to 10 minutes. So still any more queries, you're welcome. Okay, you can contact her via email. So maybe you have taken a snapshot or screenshot of that. So you can contact, or you can contact Mr. Wesley so that he can address all your queries to Dr. Alexander. Okay. Thank you very much, Dr. Alexander, once again.
Thank you.
Yeah. Yeah, and we are about to conclude the webinar now. And before that, we will go for some polling questions. So that will be displayed on the screen. So that may be helpful for us for the better organization of URF conferences. So I'm going to launch the polling now. So please answer the questions. There are questions of 8. So please be patient for a while, and you can answer the questions. That would be helpful for us. Okay, so how useful were the sessions or the trainings or the presenters? So are they extremely useful or very useful or somewhat useful or not useful at all? So you can write your experience here. Thank you. Okay. So here I would go for the next one. So we'll be having a 30 seconds of time for each question. So how did you like the webinars? Thank you very much for your response. So here I will display the third one. So your expectations of this webinar were met. Thank you for the rating. So how would you rate the presenters or trainers at this event? Thank you. So would you like to attend the similar events in the future so that are organized by United Research Forum? Yes, thank you for the positive response. Most of the people are with yes. So attend the events like this. Thank you, everyone. Thank you. So however the materials presented at this seminars, it was relevant and helpful to you. Thank you so much. And I would like to go for the last question for today. So do I present it or communicate in a clear and understandable manner? Thank you so much. And thank you everyone for almost 90% of the responses were positive. So I would like to thank each and everyone of the participant who joined the webinar today. So before concluding, so I would like to thank all the speakers, the keynote presenters, as well as the poster presenters, the oral presenters who joined this webinar for allocating the time to join these from apart from the busy schedules. Dr. Maya G. Lambreva, Dr. Varun Vohra, Dr. Miha, Dr. Sanjay Kumar, Dr. Ramesh, Dr. Shilian Zhang, Dr. Milay Santariage, Dr. Ali Wagate, Dr. Abdul Rahman Kuti, Dr. Farid Ambrosy, Dr. Atala, Dr. Soumya Sabri, Dr. Alexandra Calonia Villa. So thank you, every speaker, and as well as all the delegates who joined this webinar. And before concluding, I would like to pass on my mic to Dr. Soumya Sabri. So to just conclude the webinar with a few sentences or.
Yeah.
Thank you. At first, I'd like to thank everyone that participated in this webinar too. And it was so useful because as we saw, we have different talks in different fields. And then it lets us to get familiar with different studies, and it was so useful and conductive. And then I appreciate all the speakers that present their good studies. And also, finally, I appreciate webinar committee members that plan this program well and let us to join into the meeting and be together to get familiar with different studies. Thank you, everyone. Thank you.
Thank you very much, Dr. Samia Sabri, for accepting to conclude this webinar for the quick response as well.
You're welcome.
Yeah, it's
Thank
my
you.
pleasure.
I hope
Yeah.
to see you again. Yeah, Kai. Thank you.
Yeah, thank you so much. And I would like to allow some time for all the delegates. So if you can interact with one another by expressing your name. So what you do, so are you in research or what field you are, so you can introduce yourself to us so that we can connect to the membership for the United Research Forum. We can consider you as well. So if anyone want to bring forward or as you want to introduce yourself, now you're welcome. So we will have 2 to 3 minutes of time for your self introduction.
Yes, thank you very much for that opportunity. Hello?
Yes, Dr. Ibrahim, you can speak now. Yes.
Yes, thank you very much for that opportunity. My name is Ibrahim Huza. I'm a senior lecturer in the Air Force Institute of Technology, Kaduna, Nigeria. And then my area of research, of course, is in renewable energy. My PhD is in automotive engineering. This webinar is quite educative and interesting. I gain a lot of things in the research. And then I have gotten the email of most of the presenters, which of course it's a wonderful presentation. And then I would like to, urge them that we are going to email them, requesting them of, further, materials on the research, since I can know that they are having recent equipment and facilities over there, unlike our country here, Nigeria. So the presenters, they issued the email. I hope they will be responding to our, guidance and request in order to guide our students here in Air Force. We are doing intensive research in the renewable energy.
Yeah, thank you, Dr. Ibrahim. It's nice to meet you, and it's a pleasure. We would like to hopefully collaborate with you in future as well. So we have shared a review link so that regarding the feedback, so you can find in the open chat box here. So we would love to hear your feedback as well. So you can click on the link, or you can share your comments there about this webinar. So as well, you can contact Renewable at urfmeetings.com to attend any of the future conferences as well. So are there any more delegates that you want to introduce yourself to United Research Forum and the United Research Forum attendees or the speakers as well? So you're most welcome.
Hello.
Yes.
Yeah, I am Ruby, research scholar from Anna University, India. Currently, I am doing a research in the field of biomaterials by synthesizing of nanomaterials and going for application in the field of agricultural packaging, especially packaging the food products. So this conference is very useful and informative by combining the Department of Nanomaterials and the biological field. So it is very informative and also very helpful for other people to know about some of the research field newly in the field of, especially in the field of the biofuel cells and bio-based application. So it is very useful. In future, if you want to make a combination of application in the field of nanomaterials and it can be applied to the field of agriculture. So it's very informative, and my email ID, I will post it in the chat box for further information. And this e-conference, especially in virtual mode, make us to connect all the researchers in one forum. It is very useful and also innovative, and especially thanks for the organizer who make this conference very useful for us, especially for the researchers. Thank you so much. And my email ID will be shown in the chat box. Thank you.
Yeah, thank you, Dr. Mary Thomas, for introducing about yourself. So it was a very pleasure to meet you here. So, and definitely we will collaborate with you for the future events as well. And I will ask my colleague to contact you via email as well.
Yeah, thank you so much. And also it's very pleasure and honor for me to come back again. Thank you so much.
Yeah,
and my specialization is in the field of biotechnology and nanotechnology.
Yes, noted with thanks, and we will contact you after this webinar. Thank you.
Yeah, thank you.
So still any more that you want to introduce yourself?
Yes, so how can we get the materials? Are we receiving the materials of the conference through email?
Yeah, hello, Dr. Ibrahim. Hello. Dr. Ibrahim, I cannot hear you. Can you please explain that once again?
Yes, I'm asking of the material. Thank you.
Yeah, okay. And I would like to thank you everyone for participating in this webinar. So, and with great wishes from United Research Forum, and I would like to thank the United Research Forum committee as well as the director of United Research Forum, Dr. Anga, for allowing me this opportunity to serve as the role of moderator for United Research Forum conferences. So hopefully we will see you in the future conferences of United Research Forum. So Dr. Ruby Nimola Mary Thomas has shared her email. Ruby Nano 87@gmail.com. She's currently doing research in the field of nanobiotech application. Dr. Mary Thomas, we are very glad to meet you here as well. And Dr. Ibrahim also, we are very glad to meet you. So we'll contact you after this webinar, and we'd like to recommend you for the United Research Forum events as well. And thank you everyone once again. Have a good morning or good afternoon or good evening or good night. So because we are from all over the world, so the researchers as well as speakers are participating from the different countries. So thank you everyone. Hopefully we will see you in the next webinar. You can contact Wesley John for more details about the upcoming events. Thank you and have a great bye-bye.